Hello, everyone. Good afternoon. I don't know what is worse, before lunch or after lunch. I don't know what is procession. We'll see. Maybe we'll keep you guys will have some food in the stomach and be lively participating in this session. So now we're going to talk about geotechnical engineering. So Sharon, Aiden, and myself, Raul Velasquez, put together this session. We hope that you enjoy it. We spent a lot of time working on this. We want to thank the participants. Our office director can attest that we got sometimes too excited. He came during the time we were editing these videos and say, what's going on? Because we're just yelling and you could hear from the hallway. So hopefully that energy is transmitted through this product. Hopefully you enjoy this session as well. Before we start, we want to just go back again and talk about what we mean by implementation. So we are kind of the same page. So there's a lot of information in this slide. First, I want to thank Joseph Podolsky from our office, Office of Materials and Road Research. He's our research implementation engineer. So if you have any questions about implementation, issues with implementation, you can go and ask Joseph. But mainly we are focusing on what is showing here in green, okay? The research cycle involves 12 steps in general. And again, we are looking for the green side here, okay? When we're talking about implementation, we're talking about how to demonstrate products, how to evaluate those products. A product could be a specification, a product could be a test, a product could be a guideline, okay? Then also we talk about developing best practice and guidelines, outreach and communication, full deployment, continue to learn. So the another important thing is that we do research, we're trying to implement it, and then we think that we are done, but this is a continuous cycle that we go continuously. We have to refine that research that is coming, that comes out. So it's a continued work. I'd like to show this one too. This is kind of a brief, like a big picture of what implementation means. And we're talking about the blue zone here. So we're talking about what happened when you have context. We tend to researchers to focus too much on the details in the lab or the model in the computer, and we just get too narrow when we don't think about the conditions that are in the field, all the other parameters, all the other variables. So keep in mind that the discussion we're gonna go through in this session, we're gonna talk about how to adopt technologies between that system that you're working on, how to interact, how to work with people. People is the most important one, and sometimes the barriers to implement technology, geotechnical research, has to do with people, dealing with people. And again, get evaluation, feedback, and go through that cycle again. So I really like to see this, the analysis that we do more into a context. Keep in mind that when we're going through this session. So it's kind of different. We're trying this. We've never done this before. This discussion on these videos I'm going to be showing, the discussion focusing around two questions. Number one, what are the barriers for geotechnical research implementation? And number two, ideas that you guys have for solutions to try to remove these barriers. Some of these themes apply only to geotech, but after you hear these experts talking about their ideas, you will see that applies to all their teams, applies to any technology, concrete, asphalt, it applies to other teams, as you will notice. It took a long time to do this, and we got a lot into a fights with, I'll call her the director of these movies. We disagree in the way we should do this, who we should play first, who we should play second. You know, it's a flow, and I wish I know that one of our pavement researchers here was a before he became a pavement engineer, he was a DJ in Europe. I wish we brought him in before to help us out with the flow of who to put first, because you know, on a playlist is very important who starts playing and who you play at the end, right? Hopefully we nail it. You guys will let us at the end if we did a good job or not. So we're looking for overlapping themes. So maybe we can help solve this problem with implementation, because sometimes the industry thinks one way, the agencies ourselves think another way, and academia, of course, think another way. So we're looking for that middle point here, overlapping things that maybe can help us tackle the issue of implementation. So first, if you guys can help us out, we want to have some feedback as we go through this process, through this presentation. If you can use Mentimeter, you have that barcode. So the first question you're going to have in Mentimeter is, what hat you wear? Are you an agency? Are you industry? Or are you academia? So if you can go there, we will appreciate your participation. I will let like 30 seconds go by. Okay, you guys scan that. Then I'll jump into Mentimeter to gauge participation here in our room. Can I get out now? Everybody got it? Professor Hajj still there? I think everybody. See if I can switch. Okay. No, I mean, no wonder we have a lot of MnDOT people here. 32 DOTs, mostly probably MnDOT. We have 5 contractors. That's good. Some industry people and 7 academics. So that's good. We have a lot of agency staff. 42. Whoa. Okay, good. Thank you. So as we go along, we're gonna tell you when to go back to your phone to answer some questions. It's only four surveys, so 4 questions. So it's not gonna be a lot of homework for you guys. But you know what? Maybe it's good for you because it keep you awake after lunch. So, so now I think I'm gonna go back to the work. I was super worried about this. So the discussion is also, as we're gonna try to have the discussion in the context of 4 projects, geotech projects that were selected by the geotech team members. And those projects, because we don't have a lot of time to go into deep discussion on what the outcomes from these projects. You can ask. The PIs and the co-PIs are in the room. So if you have questions about some of these projects, you got Bora. I don't know what is Bora can ask. Is the PI, co-PI, some of them. And then we have Sohail is right there. So you have detailed questions you want to nerd up and get all fancy, you can go with them and ask questions. But this discussion is going to be around those 4 projects. The first one is been having a lot of traction, and it has to do with recycled aggregate base, the use of RCA. In our agency, that's becoming a hot, trendy topic for us. Number 2 is on freeze-thaw, predicting frost depth. Number 3 is an attempt to develop a device that can measure moisture quickly in the field. And last one is about measuring drainability of your base material, so pavement foundation. Okay. Also, the barcode there is for the NRRA website, so you can download the reports for all these projects. All these projects already completed. The motivation doing this session, the way we are doing it right now, is first to hear from as many NRRA members as possible. Second, to learn from experienced practitioners and academics. I hope that you, as Sharon and I, learn a lot from these short interviews that we put together. Third one is feedback from new young practitioners. Maybe they have a new idea to improve the way we do implementation. Maybe there is a way that we didn't see it before that can help us push forward implementing research. And what is good about this is that we have a variety of perspectives in a very concise format. That was the intent. And inspire action. So inspire action from bottom up at top bottom. So we have new generation doing the work in the field that inspires work in implementation, but also have directors and top people that can make decisions and maybe see things a little bit different as we go through sharing these thoughts to improve, again, implementation. Before we go into these videos, I want to thank the participants. Here, the list of participants. We have someone in the audience. We have Tim Anderson from MnDOT, Terry Baudry from MnDOT, David Stapp from Wisconsin DOT, Tom Yu is online right now from Federal Highway, Sinan from Wisconsin DOT, and of course, Professor Minju Khan is here, Professor Sohail, Professor Bora, and some others. So we want to really thank you. You are super busy. You spend a half hour with us doing this video, so we really appreciate it. And with that, I'm just gonna pass it to the director of this movie.
Well, Raul did a great job with the microphone, so I'm just gonna try my best, but he's hard to keep up with. So, all right, we're gonna see our first video, and this is going to be the answer. This is going to be an answer to what are the barriers for geotechnical research implementation, and let's hear from our experts now.
I find that from my experience, the barriers to the implementation of research is making sure that we're able to adjust our policies and procedures consistent with the findings of the research. Sometimes research is completed and the findings may be beneficial, but there might be some other considerations that maybe the research hasn't taken into account. And when it comes time to implement the research, it's a barrier to actually completing the full implementation. So, just sort of working through that process is trying to discuss with people the benefits of the research findings in terms of cost or efficiency or other benefits of the research findings, I think is really important in getting that buy-in from the different stakeholders or people who will be impacted by the research. I think is really key.
We need more research related to geotechnical engineering, geotechnical aspects of human systems. I know this is something that you wrote emphasized in our, the past meetings, but geotechnical research is complex. There are a lot of challenges, unknowns. We're dealing with natural materials, especially in places like where, this in cold weather environments. So there are lots of complexities involved with equipment, materials, and all that. So more research is needed. There are also technical challenges, complexities related to this. And for example, how do we simulate the real world conditions and taking into account precipitation, freeze-thaw cycles, environment, and all that. So how do we accurately, model that? And how do we gather high quality data? And again, taking advantage of, the sensors, advanced sensors, instrumentation, they will help us. But again, these are all the challenges that we are, dealing with. And again, implementing innovative geotechnical solutions, we often encounter some regulatory or institutional barriers. They need to be addressed as well. And knowledge transfer, there could be a gap between research outcomes and their application in practice. So we need to work on these areas. And there are challenges even just going from laboratory research to field research.
Well, I guess I'll just try to concentrate mostly on pavements because that's what I'm responsible for. So just standard, concrete bituminous pavement design, which includes, of course, a subgrade all the way up through the surfacing. And I think that probably the biggest barrier I see is credit's not given when we design for a strengthened subgrade or base or reclamation. So I think the way the design program is formatted, that once you hit the minimum required for, say, a 20-year bituminous, then boom, everything kind of shuts off, and therefore we don't need to look at better subgrade design, say, like with cement stabilization or a fabric, geotextile. Along with that, many times there's minimum pavement thicknesses surfacing. So you'll either have 2 or 4 inches of bituminous that's required, say. And then, okay, so then if you back that in, right, if I were to better fix the subgrade, you might be able to get to less than that, maybe a 4-inch minimum, right? So let's say a cement treat subgrade, and they go from 30,000 KSI subgrade, or maybe it's I'm not sure. We'll say 30,000. I'm not sure the units there. And if I bring it up to 100,000, then I could probably thin up my top section. But we're not giving credit for that. Along with that, good subgrade design is good you can be good for 100, 200 years, right? So I mean, there's some pavements like that were done by the Romans, and they're still there because they were done on, from the bottom up, right? So I think that's the biggest impediment. Now, we have worked somewhat with the pavement design people, and we actually did some changes within the MnPave program to put in geogrids and geosynthetics. So we're working with them there a little bit, but I still think if we really want to maximize design for long life for good subgrades, then we really have to look at those minimums that we have within MnPave. Some of the other things that we've instituted, I think we did a lot of good work with looking at a quick guide for drainage for sands and such. We had a project with University of Wisconsin recently, and I think we did really well there, to look at how when gradation changes, it affects the drainability of our products. So I think sometimes we just look at gradation only, but then when you have like higher bituminous, they have better, higher bitumen content materials have better drainability than lower bitumen content. So if we have more bitumen in the recycle, that improves recycle. So some credit should be given there.
I've been working with TxDOT primarily, and in the past I've worked with Louisiana DOT. Currently I'm working with MnDOT, also worked with Alaska DOT. So I think some of the agencies have a wonderful like a way of accommodating our barriers. So one of the major barriers is like, I'll give you an example in my area. If we want to try a new material, a new construction method, a new processes, we can do that in a small scale in the lab. Then the next thing we have to do is to see if that method that worked in the lab or even a small scale setting can mimic well in the real field conditions. So that is to us the big barrier sometimes, So and sometimes also like the small barriers like everything that looks very expensive at the lab scale, I'll give you an example of a geopolymer method. And we're trying to call it a sustainable method. When we looked at it, the cost of preparing in the lab scale is going to be a little bit high. So it's really not sustainable from an economics point of view. So, but then if a company does a lot of manufacturing, they make the product much cheaper, that becomes very sustainable and carbon friendly material. So sometimes even the major barriers from an academic point of myself, from a research side, does it mimic well in the real field conditions? Can I upscale this technology that I'm developing in my lab into a large scale field implementation which can provide a lot of cost benefits? And the second thing is a lot of things, because sustainability is nowadays very important. Initially, these things may not show sustainability at a smaller, lower scale, but we should stop there. We should really actually make it go. Because down the line, some of these products, when other big industries will pick up, you will have these prices will come down, then it will show sustainability. So as a faculty researcher, I have to always put the hat, is something going to work well, or there is something that I need to do some changes, or I should be upfront, about some of the issues related to cost or manufacturing challenges. All those things I need to provide them and then give them a roadmap on how subsequent studies, particularly a full-scale field implementation, like you have wonderful loop with your NRRA area there outside in Minneapolis. Those things were really very helpful, And fortunately, with TxDOT also, I do the same thing. We have one very interesting work right now on geothermal. Believe it or not, we started from synthesis to lab scale to a little bit of a bigger section in lab scale to the full scale bridge now we have in Dallas. And that's to be a classic example. We have so many barriers we've overcome in every case.
I mean, I've been in this business for about 40 years. So I see three major points to be considered. One is usually the decision makers are conservative and the contractors are conservative. They don't have appetite for new technologies, especially if it's not perfected. And the other one that I see is the need for perfection before implementation. So everybody wants it to be perfect before they want to implement it. Then they get to a chicken and egg situation that you need access to collect data and improve the methodology versus not being able to get to the sites because the technology is not perfect. And then there's always the concern of especially the construction crew is about impeding the progress of the construction by implementing new technologies.
I think that the main challenge is the direct collaboration between the industry and the researcher. And often when researchers write a proposal, that discussion starts and then it goes away until the end of the project that they want to really implement. I think the implementation process is not very clear often in research scope. There is, for example, when you write a proposal at the end, or that some parts of the proposal, the project scope, there is a section that says what are the implementation strategies, but it's not very specific, and that's often lost in the process. And I think that clarification and the implementation discussion, and if they are in different stages, it doesn't go stop all the way until to the end. That's important.
You know, for me, you know, I'm just skip the low hanging fruit of funding because that's always the challenge, right? But you know, for us, you know, as a company and manufacturer, we have a product whose name might be on the line here, right? So our reputation is at stake with every single research project, and we want to know more about where products can do good or bad. But I think the key is having a good team of trust that can do the research properly, right? And that's challenging. So, you know, for us, we like to really be involved in the research so we know they understand what product they're using, how it works, how we understand it works, and things along those lines. So there's, you know, no surprises for something that might not go as expected, right? So just having a good quality team and communication, I think, are the critical parts of geotech research on our side, because, you know, we don't want our products looking bad because of an oversight, right? If they don't perform well, they don't perform well, but there's something else, there's an error, whether it's installation, or monitoring, or instrumentation, things like that. Those are things we really want to avoid, and we'd like to be involved and make sure that doesn't happen. So, but that was my main thought. So, how about you, Danny?
Yeah, thanks, and very good to be video, and thanks for this opportunity to be able to discuss this great topic. You know, based on my understanding, one of the most significant barriers for geotechnical research implementation is the natural conservatism of the construction and civil engineering industry, because, you know, this field is often relies on the proven old method instead of adopting new technologies because of the high stakes related to the infrastructure project. And that may cause reluctance to adopt new technologies or innovative materials or innovative solutions for geotechnical problems. And I'm trying to provide my general opinion, but I'm more focusing on the industry side of things. You know, the other thing is the regulatory environment could be tough sometimes, because if you have an innovative material or new solution, they have to go through extensive amount of testing and approval process. And it can be not only time consuming, but also costly. And there's a financial risk associated with the research and development for geotechnical solutions, especially the innovative ones. And for most of geotechnical projects, the initial cost, the initial investment is significant. And without solid evidence of potential return of investment or market demand, it's going to be tough to secure funding for those projects. And, you know, this challenge is even made greater with the difficulty of translating the small scale laboratory testing to the large field job, real world project or practical applications, because they often need extensive amount of customization or further investment for the projects.
Yep, and Jason, you're spot on too. You know, there is, you know, this challenge of timeliness. I don't know how to say it well, but, you know, we need about 10, 12 years of research and installation before people start getting comfortable with some of our products, right? So there is a big financial upfront cost on the manufacturing side. And so we support all this research, absolutely, and we try to do everything we can to speed up that process, but it is slow regardless, and people generally have their comfort zone, right? And you need to overwhelm them with abundant evidence that this technology or whatever can do what it can do to make them feel comfortable, and that just takes time, unfortunately.
Exactly.
There may be several, but the main barriers that I have been seeing is the sometimes disconnect between the academic research in particularly, and the practicality of it, and sometimes in some of the projects, the academic researchers may go too much in details and specifics, which may not have any implementation value at the end of the day. So there is a part that may be that is sometimes challenging, especially depending on the topic of the research project. And the second part, for implementation, sometimes you needed more through research to really implement some of the research results. And majority of the researches that are funded are 2 to 3 years most of the time on average. But sometimes to implement it, either you fund projects consecutively in different phases, or you fund one project that takes 5 to 6, maybe even 7 years sometimes to really implement some of the researches. So that project duration sometimes can be one of the barriers. And another part, the third one, is the research projects sometimes giving you new ideas or giving the outcome that were surprising, and maybe the implementation research on top of that is one of the barriers that I would see. And the last one, I think the lack of training and webinar or implementation presentation is lacking on these projects. So I kind of see people who will implement it kind of disconnected from the research.
Say that this project was really driven from the beginning by the desire to lower barriers for implementation. That this is a project about drainability of roadway base materials and recognition that drainability is an unsaturated soil mechanics problem. We've got to consider both hydraulic conductivity and water retention characteristics, neither of which are routinely measured, I would say. In particular, water retention characteristics, measuring the soil water characteristic curve is not often done. It's expensive and time consuming. And so that was really the driver for this project, was to try and come up with ways to incorporate the actual physics of the problem that are working in an implementable way. So really what we did was try to come up with surrogate properties that could be more easily measured and used to estimate hydraulic properties that matter for base course drainability. So both saturated hydraulic conductivity and water retention curves. We did this using materials that were representative of base course materials. We obtained something like 15 or 16 samples from various NRRA stakeholders and measured saturated conductivity and water retention curves, and then looked at grain size distribution was a big one. We had fairly good correlation with easily measured grain size distribution indices. Percent fines we correlated to saturated hydraulic conductivity, and ways to predict the water retention curve. And it really worked quite well. And it was a data set that was, constrained to base course materials. And so I think it could be generalizable for other materials that are used in those applications. So that was kind of one part of really, one of the drivers for this project. The other was to develop a rating system to say, can we take these easily measured parameters and use them as screening parameters to say this material is should perform, we would expect based on these measurements, as an excellent draining material. This one, even though it might meet grain size specifications, that's one of the things that we found, is that base materials that may meet grain size specification windows don't necessarily perform optimally in terms of drainage. And so those are kind of the lessons learned from this project. And again, in terms of implementation, that was the idea, to try and kind of lower the boundary of unsaturated soil mechanics to the point where people could use it. And hopefully we'll be able to do that.
The barriers for implementation,
one of the projects I implemented was the DCP, minerals and ingredient base. It took about 3 to 4 years to implement that. You have to start on a small scale, one project or two a year. And you got to make sure that the people that see the benefits, people that are implementing anything, especially this, you show them that the testing was faster, which was a good buy-in as far as the construction folks were concerned. And then first year we had 2 projects, next year we had 4 projects. And once people understand what's going on, and also we did modify the leg of the DCP. It used to be 36 inches. We brought it down to 24 inches so people can actually use the device. So all those years, we had to provide support out in the field. If there was problems, you need to go out there right away to figure out what issues have they come up with or what's the limitations of the device. So the main thing is you have to be persuasive. You also look to make sure they see the positive of the pros of using anything. Another example is implementing the MEPDG or mechanistic empirical design among the materials engineers. That again took about 3 to 4 years. One way of doing it is have the materials engineers use the old design process and then the new ones so they can get comfortable. There for a while, I was strictly using the MnPave program, just a mechanistic empirical design program that was developed by MnDOT. And then once they have an understanding, their feeling, get used to it, then it was easier to transition over. And it helped when we more or less mandated that we'll be just using MnPave and not the other old programs. When we came out in 2014 with the pavement design manual.
As an agency DOT, the big barrier I have found is like, we do a lot of research in controlled environment, and there's some in seen in real world and in other roads, and also we try to use very specified equipments for testing. And but in reality, in DOTs, in our place, we don't have those equipments. So those are the things. And the main big issue about implementation is DOT, like accountants, we need specifications and plans. Anything we develop to research, we find out a good part and any information to implement those to materialize this research output. We need to have side by side specifications as well as guide implementations. And also what are the possible issues we have to cover and what it could do. So it has to be really detailed, should be detailed in guidelines. So that will help we implement any geotechnical research studies, especially for pavement. For example, let's say we know that geogrid or geotextile will perform, definitely perform. But the problem is how to implement, how to put it in design in MEPDG, how to implement, how to model it. There's so many types. So one model may not fit for everything. So those are the kind of material-based spec. It is not possible, but somehow we can have a really guidance on that will help to implement in real world in construction.
There are primarily 2 barriers in geotech research implementation from my perspective. The first barrier is the limited accessibility of research findings. Often, geotech research delves deeply into scientific observations and verification of new findings. to advance science and engineering, which is of great importance. However, often this results in outputs that requires extensive prior knowledge and can appear overly complex. And this can be a barrier to broader accessibility and application of geotech research findings. And the second barrier is the engineers' lack of confidence or belief in new technologies or research findings. And this skepticism often stems from a conservative outlook within the geotech field, where conventional methods are preferred because they are perceived as sufficiently effective from the previous experience.
I think the main barrier is that the need for good pavement foundation is not captured in pavement design analysis. Because the way we design pavements, they're based on mechanistic analysis. And whenever we do analyze pavement that way, what shows up are the stiffnesses of layers. The stiffness and strengths are important for those types of analysis. So when we do that type of analysis, effects of foundation don't really show up very well because the surface layers are so much stiffer than the layers underneath. They completely overshadow whatever we place underneath. So and we base all our designs based on those results. And I think that is why the importance of good pavement foundation is difficult to implement. Of course, if you talk to DOT folks, I think everybody recognizes need for good foundation, but on the other hand, by analytical means, we can't show the benefits, so it becomes difficult to implement that. So I think that to me that is the biggest failure especially now as we move more into mechanistic empirical type of design process. The importance of good pavement foundation is getting overlooked.
I find.
All right. Thanks again for our, for interviews to our participants. So I believe the video itself was pretty self-explanatory. So now I'm just going to summarize to see what are some keywords or what are the main themes, or are we going to see some overlapping between different perspectives, which might be hopefully an inspiration for us to do a better job when it comes to implementation. So Raul just changed the question in Mentimeter, so you don't have to rescan the QR code over there. You are probably seeing a new question. And we appreciate if you can put what you think is a barrier, the biggest barrier, a word or two for the geotechnical research implementation. You can either use the one that I'm just about to show, or maybe we have missed some points that you can just point out and we can do, much better in terms of implementing our research outcomes. And let's look at the academia. We see that one of the shining stars when it comes to barriers is ignorance of the foundation layers, ignorance of how important foundation layers for the overall structural capacity of pavement systems. And also we see that incomplete research or need for, the sensitivity of the implementation process. Transition to implementation is also a barrier from the agency perspective. For industry perspective, unfortunately, we weren't able to hear much from our industry partners. And maybe just by itself that tell us that we need to do better, maybe in collaborating, because we weren't able to hear much. But they pointed out that having or not having a good research team sometimes might be a barrier. Let's see academia. So academia had a lot to say, and we always appreciate their feedback. So complexity, low sustainability, not having a holistic approach and modeling the field condition, and having barriers, industrial and regulatory barriers, they were also main barriers for geotechnical research implementation. Now let's take a look at if we have any overlap. We see that industry and academia has they have some overlapping on the risk, collaboration, research duration. Conservatism was also one of the most popular one, along with the cost and also technology transfer. However, when we look at if we have anything in common coming from three different perspectives, we see that field application right there, which is the upscaling, which is how we can actually do better when we are taking our research output coming from very controlled laboratory environments, and how we can actually use those results to, to do a better job in the field was the common barriers. So now I think if you already put, or maybe you're still putting your, feedbacks when it comes to barriers, let's take a look at it. All right, I see cost right in the middle, conservatism, trust, yes. Scalability, yes, that is having, the field application and upscaling. We see that education, technical trust. So as far as I see, we have parallel comments following what we have heard from our experts. And this will be going on, but I can see that cost, conservatism, risk, buy-in, and trust is becoming one of the major barriers also coming from our audience. We really appreciate your feedback here. All right, so we have heard about the barriers. Maybe we found some solutions to them, maybe we have not. So let's hear from our experts. What are those solutions to remove barriers for implementation?
No. As far as improving the process, I think just working better with pavement design section, because they're the other unit. So when I get when I have a research project, right, or a pre-research project that I'm involved in, all I need to do is change the specifications and testing procedures, and I have all the opportunity to change all that, by myself. I have, I do vet it out to individuals when I'm going to change my specifications or the gradient and base manual, say. But usually it's more or less rubber stamp. I get very little pushback at changing the specs. But now to implement that and say, okay, now we've got this new method, I think it's worth, that since the resilient modulus is going to go way up, we should look at how this is going to affect the topping set. So it's just better working with our pavement design people to get that implemented in their design process. Now, another thing is to get the word out, right? So once we've done it, the project, I do have the opportunity. I do have the opportunity to speak in front of locals, the materials, our own staff, materials engineers, and soils engineers. So I think I'm given pretty good opportunity to get the word out that here's a great process. Here's our test results. I think you should do it. But by and large, that next step, like I said, is done by somebody else. So I can't make them do something that I think is a good idea. But all I can do is encourage it.
And I think one of the important things to do is continued recognition that unsaturated soil mechanics is really what's controlling the physics of this problem in particular, and so many others like slope stability and other problems. Recognition that of the physics that are happening, and then figuring out ways to implement that physics in a way that's not cost prohibitive or time prohibitive as it has been in the past. I think holistic consideration of, again, in terms of pavement drainage, the pavement surface, the subsurface, the subgrade, and the environment. This is all one big sort of circle, and all of those things need to be included as a system to really get to a problem like this. I think that field measurements are important. The study that we did was focused entirely in the lab. I think that demonstration of the value really takes field work. And so that's something I'm hopeful that we'll be able to do at one point, is take some of these ideas developed in this lab project, extend them to controlled field conditions to further demonstrate the value of considering unsaturated soil mechanics. See if we can show that the product is better or lasts longer, that it becomes worth it, for example, to make these more complex measurements, or to at least estimate them as we showed here.
More training, more workshops on conferences. This could be nationwide TRD or NRRA conferences, or even whatever the funding these research projects are for. Those local conferences would be one of the way to do not only one webinar or one workshop, maybe every quarter after research is finished, maybe every quarter the next 2 years, such trainings keep provided depending on the topic of the project. Of course, I think that's one of the options that I see that may improve and remove the barriers. And the second one, definitely need to have practitioners and engineers who are going to apply this in the field. Needs to be not only one, maybe 2, 3 of them in the research technical advisory panel, to kind of see, kind of help to guide the research project in addition to the technical layers. And in some projects that exist, and in some of the projects it doesn't exist. And I think that causes an issue. The implementation engineer really needs to be involved in these projects, so they know what are the outcomes are for. And even when you're running the research, they kind of tell, hey, I don't see a way to implement it. Kind of related to the last thing that I said, if the engineer feels like, how am I going to implement it? This research results are good, but implementation, I have no clue at the moment how to implement it. That's why those research maybe follow up with an implementation research.
From my experience, to help the implementation, I think at the start of the project and all the way throughout the project, coming from the other parts that I answered, we need to have the clear definition. First, the clear definition of what the implementation means at different steps of the project. And I really recommend that maybe the funding organization or whoever manage the research from different academia or industry, they put a specific budget for the implementation effort. So often as a researcher, we go deep into fundamental knowledge, or really we are doing all these nice things and want to do more and more. And basically we use all the resources that we have to do the best we can to accomplish the task that's given to us. But at the end, it comes to implementation, we say, okay, this project this product is ready, but now time is up and we need to write a report and everything. And we say, okay, you are available for presenting. But I think maybe through this funding process, if let's say there are different tasks and there's a task of implementation and there's a specific budget for that task, that could be in any form. It could be like traveling to different DOTs or presenting, or like organizing a set of webinars, or like, I don't know, organizing a workshop. But each project, 2 things. One, the implementation process should be very clear and specific, even if it's not complete. You know, if there's a part of the project that this 2-3 year project addresses, but the implementation process is clear. But also there's a specific funding that is just for that implementation step, that the PI or the researcher know that in order to use that resource, they need to do these 3 things. That way, we consider that as part of the project, not as a secondary thing that we need to do. And I think there are different ways of implementation. Like, for example, as I mentioned, webinars, workshops, or sometimes a shadow project. Say, okay, this is our research project, and you have an extra some $1,000 for shadow project that is specifically for implementation. When you finish this, you can apply that implementation fund, which really you use it for just that purpose. It's not just extra research or anything. When you finish it, the reports are accepted. Now you move on to the next phase, which is there's some money that will do to just do the work and really disseminate the results. I think just this is really will be helpful because it has its own line. It's not something that's lost in all other tests.
I would like a combination of what TxDOT and MnDOT does. TxDOT, after the research project is finished, they will just fund the implementation projects to perfect it to some degree. MnDOT, I like the system of the patients and working collaboration with the contractors, and everybody is involved, incentivizing the contractors to allow access to the sites, dedicating a person to collect the data and analyze the data and champion it, and that's what we see. We really need collaboration between the DOT engineers and contractors, and we need these to work closely with academia, because as academicians, we are good at making things complex, but making it usable for the industry, that's another issue. So that's the way I think that you can go, just patience and just resources to implement and perfect things before it becomes perfect.
I can mention a couple of champions from TxDOT. When I have certain ideas, I took them to research division at Austin. I have some folks from the Austin, and also I have some folks from the TxDOT districts who actually, they said, okay, we should try because what we're currently doing is not working. I give you a topic like sulfate soil heaving, which is one area where I made a pretty good name for myself and my group and all the things that we have done here. That is one area where we really invested a lot of time. And for that work to do well, we have some champions like TxDOT materials engineers, like one of my friends, Richard Gilliland. I worked with him in Fort Worth district, and when we explained to him, he thought it was the idea to pursue. So we developed a research statement, we worked on it. Then subsequently, that topic went into full-scale field implementation because we were able to show how to reduce some of these heave minerals that are forming with the regular traditional stabilization methods. So without that kind of championship from Richard or other friends that I have, it's very difficult to take them because as a young academic, but at that time, maybe I'm not really young at that time, but still, when you go and give an idea, a lot of times it's going to be challenging because we really don't have a way of getting into the field, unless you have some champions who can say, okay, we can try a test section. That's where we did it, and that's where actually it now went into implementable products, and I'm very proud it was chosen as one of the Astro Showcase 4 years back, and we presented that at the Astro Showcase in the TRB in Washington, DC. There are some folks that have been in this research area, so they know how to polish their proposal. But a lot of times I try to learn by going to some of these conferences that has like industry focus. That's where like TRB is one big place. TRB, where when you attend the company meetings or like a lot of the sessions, you get a lot of great ideas from some of the folks, and if I want to develop a proposal, I need to look in all angles. And I tell this to my young PhD students working also. Don't also always just look at a simple improvement from a lab scale. Try to see whether this can be constructible in the field. And then also, what are the potential barriers in the field? I mean, to give you an example, one time we were doing a kind of a slag cement in a project for the city of Arlington. And when we started doing it first day, we created a dust, that was a very fine material, and that area is very windy. And then I was worried because it's going to create a lot of issues from the people living in that street area. So I ended up talking to our city folks, and we tried to do it between after 10 o'clock in the morning, and then before 3 o'clock, because that's when people are either working or not at home, or very few people are there. And we did that, and actually they were happy. and there were not many issues at that time. But some of these like things will come if you put yourself into you have to think from others' perspective, not just from academic perspective. I would just only want to check the improvements. That's not enough. You need to think out of box to see whether this is constructible. Or if it's constructible, what kind of things that I need, what type of mixing machines I need, and then do we need to mix with that, in a wet form or dry form, or is a dry form going to create any air pollution issues and all those kind of things. So this is the things you will only learn once you start attending some of these conferences where you get the point of views from other side, and which is something I always tell our folks. Either I work on a geosynthetic projects, or now I'm working on geothermal project. We always work with the industry base. Sometimes we even have within a project we have a small 1 or 2 member group where we can go and tell them what we are experiencing, and they give a lot of times feedback. And those 1 or 2 members should not be another academics. I want to bring them from outside, either from someone with a DOT background or someone from an industry background or contracting background. That person is the one we needed because he will bring a different point of view. And I don't know, I want to give you a quick example. Recently, we were doing a proposal for one of the US DOT project. We were all thinking, okay, what we're developing is a very good sustainable thing. So we did everything. Then we presented this to one member from which I don't have, first time I met him, is US Army Corps of Engineers. And during our meeting, he said something which actually made me feel like, oh my God, why didn't I think about that? If this is something a kind of using a materials for like a erosion control, but then he said that is like putting some plastics into the area and it's exposed to the water. I kind of knew a little bit, but I did not think too far about it. But that when he mentioned, and now that may not work for nowadays, we are looking at plastics as an issue, which I know for the last 3-4 years we are hearing a lot of things. So then I started looking back, and then I told my group, we need to regroup and revisit it. So this thing really helped us quite a bit. So this is something you have to open your idea. Don't get disappointed if your idea like somebody throwing stones at it, or even saying that it won't work. You listen to them. There is something that you can really learn from them.
And I'm just reiterate, I think it's just communication and participation, right? And it has to go on. Every participant needs to have kind of an open mind to these concepts and ideas. We certainly, we talk about conservative, but we don't want to accept too much risk either. We need to do this research to validate the performance. Once we have that, people need to trust that research and have confidence in it too. We get a lot of cases where people just want to try something out, and then it takes 3 years for them to maybe get comfortable. Well, you've had this benefit a lot sooner if you're willing to just kind of accept what other people have done, right? People always want to see it for themselves. And I'm going to say, hey, no, look, we've done this here, here, and here. Talk to them, whatever you need, and just speed up this timeline a little bit. And it's advantageous for everyone, not just on the manufacturing or industrial side, but we think you're getting a better product in the end, or saving costs or something along those lines. So you can have that advantage sooner rather than later. You're just more open to these ideas and kind of accept trust other research that's done elsewhere.
I believe we need, it's not a single approach, so we need a multi-faceted approach, maybe, enhancing the collaboration between industry, academia, and government would be incredibly beneficial. By making this partnership that they can share risks and resources, we can lessen the financial load on individual organizations and speed up the process of turning a small scale job to the more practical application for the real world. And also, so I mentioned the regulators, so maybe we can encourage regulatory people to work closely with industry leaders, with research institutes, and in my opinion, that can streamline the approval process. Or maybe we can establish some dedicated pathways or frameworks specifically for innovative findings from geotechnical research for innovative materials. And that one also can speed up the laboratory testing and approval process for the regulation. And while we can speed up while we can keep the effectiveness and safety standard high. And also we can the demonstration, we can demonstrate the economic benefit or operational benefit through if we have any pilot projects that would be very beneficial. That can actually help overcome the industry conservatism probably. And we can use those cases as a proof case for the findings from the geotech research. And also they can help establish new business case for further adoption, like for long-term performance investigation, for long-term saving investigation that can justify the big initial investment for geotech projects. And also, this is, in my opinion, is really important that the education and training. So with integration of the findings from the research, especially NRRA doing some, really innovative research studies. So in integrating findings from those research studies into continuing education of professionals in this field, we can always boost up the awareness and understanding about the innovative materials or innovative solutions. And with this gradual increase of knowledge, we can shift the industry norms, we can shift the industry expectation towards using more innovative solutions based on the research studies.
For the first barrier, to address the first barrier, the limited accessibility of research findings, geotech researchers should focus more on enhancing the accessibility of their findings and creating more opportunities or platforms for research synthesis or summaries could be helpful in making complex research more understandable and applicable for engineers. And regarding the second barrier, the lack of confidence in or belief in new technologies. Increasing confidence in new technologies requires providing more opportunities for the application of research in real-world settings. So full-scale studies and field verifications can provide compelling evidence that supports lab-derived innovations. So there need to be more opportunities for such full-scale and field verification studies. And additionally, implementing policies that incentivize the adoption of new technologies in geotechnical projects could help overcome the conservative tendencies in the field by encouraging more engineers to trust and adopt the innovative solutions from researchers.
And from my experience, it starts right when you're developing the research idea concept, is trying to engage people within the agency or maybe external partners that might be impacted by the research. It could be consultants or contractors that may have some very good feedback that you need to take into account. I think if you can get a broad idea of how this research may be beneficial, but also some of the other side effects that could occur from implementing this research. I think that goes a long way into generating a project that may have implementable and really beneficial results. So I think communication is key, getting feedback and getting buy-in from various people within throughout the agency that will be impacted by potential changes from the research findings is really key. I would say, so a lot of my questions were obviously informed by recent experiences. So we've had some research projects, for instance, looking at geogrid tensile strength testing, where they were, as soon as they were done, they were implemented right away because we were changing our policies to basically go with the latest test method, and that it was a little bit more straightforward. It's just a matter of calibrating what we wanted our acceptance criteria to be and how we wanted to do the testing and so on. So that was pretty straightforward, but we have some other research projects that have been more difficult to get buy-in for implementation, and one that I'm thinking of, or maybe not even implementation, but just sort of furthering the cause is like geotechnical asset management in terms of slopes, where we completed a research project. The research team, and I was the chair of that project oversight committee, thought we had a really, powerful project. We had a really excellent researcher that we felt really gave us some, really good results. But taking that research further, basically finding the funding to then take it to the next step is proven difficult. And one of the, in terms of geotechnical asset management, one of the difficult things that people really need to understand is that, geotechnical asset management isn't part of a transportation asset management plan. It's not part of the regulatory requirement at the federal level. So it's sort of optional. So you need to find value in the research as far as, the benefit of geotechnical asset management. It's going to cost us something up front, but there has to be some measurable benefit. And that's been difficult to prove and to advance. So I think that's one thing that we're working on, trying to find ways that we can basically, for relatively low cost, try to advance it so that we can maybe, continue to make progress in that regard. We hold NRRA in high regard and all the impactful research that is completed through NRRA. And, we're actually building upon one of our research projects that will be starting in 2024 has some elements that was developed in NRRA in terms of looking at permeability or hydraulic conductivity of bases, as far as our drainability of bases. And for Wisconsin DOT, we're looking at how drainability of bases and the overall drainability of our pavement section, how we can maybe make some adjustments to improve or reduce the occurrences of pavement buckling. And there's some evidence that moisture in pavement may be correlated to pavement buckling occurrences. We're not saying it's maybe the major factor, but it could be contributing in some way. So we're looking at making some adjustments to potentially at least researching adjustments to our base course gradations that would improve the drainability, and also improve the drainability of our pavement section. But as I mentioned in one of my earlier responses, the important thing about that is when you talk to contractors, they have a real interest in making sure that the base course material that are used on projects is something that they can travel on, as far as with rubber tire wheeled equipment. They are not in favor of open graded base, because driving a dump truck on it and turning on that material especially can be problematic, where trucks can get bogged down and axles can break when things start spinning. So I think that sort of demonstrates the benefit of what NRRA has done, how we hope to maybe build on that for our own needs, and then also taking into account different stakeholders that have a real interest in making sure that the product not only maybe addresses or improves the condition we're looking to solve, but then doesn't have some side effect that would actually make it more problematic in other respects. Now I can provide other examples. Currently, we have a frost susceptibility pavements project. We're looking at freeze thaw, seasonal weight restriction limits that we put on our roads. And I know NRRA has also been very active in that realm. So I think with the University of New Hampshire has done a lot of really good work that we reviewed in looking in developing that project statement. And it's been informed by not only NRRA but other research projects that have been done in the northern states that have this issue that and we're trying to improve upon how we handle it.
We need more collaboration between government, industry, and academia, and hopefully this will also, lead to having additional more funding that we need to deal with all these complexities, that we just talked about. And let's say I touched on advanced simulation techniques in the earlier question, and how do we model these environments? And again, we need to bring advanced modeling techniques like finite tolerance programs, and we need to take advantage of artificial intelligence, machine learning, deep learning tools, because we are facing significant challenges, and we need to be smart and take advantage of all the innovations and advances taking place in other fields and bring them into our field, and so that we can actually tackle these, problems. And we need high quality data, more data to compare what's actually happening in the real environment field versus how we're actually modeling these systems. And again, to do that, we need sensors. We need more data, more sensors, so that we can actually gather a lot of data and look at the differences between models and what's actually happening in the real environment. And to solve some of these problems, we need to look into transdisciplinary research. For example, some of our research studies that we've been involved with, we work with soil scientists and climate scientists, and along with parents, geotechnical, civil engineers, so that we can actually have a thorough understanding of the challenges that we are dealing with. And we need more education and outreach, and we need to strengthen the link between research outcomes and practical application through workshops, seminars, conferences, meetings, and the NRRA has already been doing these things. We need more of these so that we can bring all these parties together, and it will help close the gap between education and outreach and implementation.
Improve or to remove this barrier, and definitely we need specifications which should be ready to use, and also we need guidelines or guide. So if it is possible, so if it is, then it should be incorporated in design tools. Mostly payments are now designed based on MPDZ. If you can incorporate it in these design tools, this material, then it will be easy to use. Because the designer will try to use what is the materials available in their tool, in their data. They will not create a new one because they don't want to spend that much time. That's the big issue, the one I find. And also there are some gray areas about influence of basis or subgrade in design. For example, if you look at an MEPDZ design for concrete pavement, so influence of subgrade, influence of basis or subbasis is very less. So it doesn't mean we don't need it. We need a very stable base, really durable base. If you don't have base or foundation, then whatever you put your pavement on, it's not going to last. So we must have a kind of specification, a kind of guidelines for the design of really durable, long-lasting bases. Even though its influence is not captured in concrete pavement, because the way the concrete pavement is designed based on cracking. So that is the reason. So those are the gray areas, and we need to mention to the engineer. Those are the things we have to consider. Even though it is not that much influence to get it for design, specific thickness, but you have to consider it. You must have minimum certain requirement or certain maybe strength or thickness, or it depends on whatever the subject material is there. Because we cannot change nature, we cannot change subject, but we as engineers, we design based on that subject or native material, so our pavement can last for a long time.
I've struggled with this for a long time because I've been keep promoting the idea that we need to improve pavement foundation design. But until very recently, I wasn't quite sure what needed to be done. But now I think the idea is, at least to me, in my mind, is very clear. And I think what is needed is that we need to recognize the different requirements we have for pavement foundation and surface layers and treat it as such. When we're designing pavement surface, what is important is again the stiffness, strength. So we design for fatigue life, but at the end of the day, all we end up designing is the thickness of the surface layer, because what is underneath don't really show up on this analysis. Now, for pavement foundation, what is important to recognize that the principal function of the pavement foundation layers is that they need to retain their integrity throughout the life of the roadway. I say the roadway rather than pavement because ideally it would be best if we don't ever have to touch the pavement foundation, because we have pavements in so many congested areas. Every time we have to go deeper than surface, it becomes a major headache. And why would we want to keep replacing pavements anyway? So I think it makes sense to design a more permanent pavement foundation. And we have to recognize the design requirements for that. And the key factor, the main thing we need for when it comes to the design requirement for pavement foundation, again, is for the layers to retain their integrity throughout the life of the roadway. That means that they need to not get contaminated, not become loose through the compaction, and we don't have drainage issues. So I think what is really needed is more or less formalizing the process for designing pavement foundation, because the practice varies widely from state to state. Some states do much better than others. And some of them, that's out of necessity because they have a lot of frost issues. So they're used to providing more substantial foundation, and they carry that to other sections. So, I mean, to be a bit more ambitious, I think what is needed is we need something like NCHRP 137A, which developed mechanistic empirical pavement design procedures for the surface layers. I think we need something similar for the pavement foundation layers and design pavement foundation separately from the surface layers. And I think that'll be really the way to resolve this issue.
No.
All right, hopefully you're still with us. Now I'm going to summarize it, and hopefully you guys are going to wake up if you're sleeping. All right, let's see what agency perspective brought us. The emphasis on foundations and how to actually use and see the contribution of foundation to the design procedure. And being open-minded, taking risk and risk sharing came from industry. And academia, I think champions and implementation phase, having separate implementation phase, they were one of the most important solutions. And we see more overlap between agency and industries, but overall, the main overlap here for coming from all these perspectives was with spreading the word and collaboration, and of course, mutual learning, because there's only so much we can know and learn by ourselves. We need to listen to each other. I guess it is amazing that we are in this room with the rigid team, flexible team, intelligent construction technology, and the preventive maintenance team, because we need to keep learning from each other so we can do better jobs creating and building more sustainable and also cost-effective payments. And we're going to have the same concept with the Mentimeter. We are going to right now ask your opinions how to remove these solutions. If you're not too tired, we please appreciate if you put a word or two. What are these solutions for you to remove barriers for implementation? And yeah, let's see. Okay, maybe less video duration is the one of the most or better solutions. All right, I see communication, patience, that's really important. Patience, I see patience located in the center, communication, more data, good plan. And I think we can say that communication, patience, and collaborations are the champions, I think. And we can move forward to our presentation by ending our presentation, actually simply saying thank you to everyone, both participants and everybody in this room. And hopefully we have one more question and to see how we are doing at the implementation, and maybe we can switch to that before you say the final words. Okay, let's see, have we done enough research or are we doing a good job implementing our research? And let's get your final thoughts, and I'm going to hand the microphone to Raul to wrap the session. Thank you so much.
We'll see the results later. We want to thank everyone. Sorry for the next session. We're taking a few more minutes. Sorry, guys. But I just want to show the last slide.
Yeah.
This is very important. The most important slide. Okay, so Sharon and I came up with, I was trying to make another Mentimeter to put a ranking for who has the best smile. But we didn't have time to do it. So number one, whoever gets the best smile is gonna get a good Metcalfe. I'm originally from Colombia, so I'm gonna bring it myself. And then Sharon's from Turkey. She's gonna get what's the name?
Baklava.
For number two. So these are the names of the participants. Informally, just come to us. So we will do informally. We'll do a ranking here. So just come after the session. Remember, I mean, we already have our favorites. My favorite is David. That's why he's in the middle. And so anyway, so come up to us, let us know who had the best smile, and we'll do those. We'll give that award later on throughout this year to the top two. Thank you. And I'm so sorry for the flexible team. We took some time.
We are going to transition to the flexible team here.
Okay. Okay, so good afternoon, everyone, and welcome to the flexible team implementation track this morning. And so this afternoon, the flexible team is, we're going to be focusing on how NRRA member states are implementing balanced mix design practices into their design of their asphalt mixes. So today we have representatives from 5 states, and they're going to present their state's experiences in implementation of balanced mix design and where they are in the process at this point. And the names of the presenters are Erik Lyngdal from Wisconsin, Jacob Graessle from Missouri, and Metcalfe from Montana, Aaron Perez from North Dakota, and Ian Gilhooly, excuse me, from Illinois. And so before though we hear from the state's perspectives, we're going to hear a presentation from Dr. Elie Hajj, who is a professor at the University of Nevada-Reno, and he will be presenting on the National West Coast Perspective of Balanced Mix Design Implementation, FHWA efforts, and the Nevada experience. So please welcome Dr. Elie Hajj.
All right, good afternoon, everyone, and thank you for having me here. It's a pleasure. It's my first time attending the NRRA meeting, and I think with the session, the geotechnical session before us, we have a very strong foundation now to go into a flexible pavement. So that being said, you haven't heard about balanced mix designs throughout the day yet, so I think we should. Now it's being a hot topic, so I'm here to talk a little bit about what's the FHWA efforts in that area, and then also a little bit of update on a few states from the West of what they're doing with the balanced mix design before we hear from 5 different states afterwards. Because I'm doing this and I'm using informations that is part of our cooperative agreement with the Federal Highway Administrations, I need actually to acknowledge my co-authors, Tim Aschenbrenner and Derek Nearplant. All of you probably have met them before throughout different workshops and so forth. So a lot of the materials that I'm going to be presenting here today is coming from that FHWA UNR cooperative agreement. And I have to also present for you the disclaimer that comes with it. And making sure that the presentations do not have the force and effect of law and are not meant to bind the public in any way. All right, and all the materials presented over here is for information purposes only. Okay, you may agree, you may disagree, you may take it and do something with it, you may not, but that's basically really and summary what it is. And then all the standards are just mentioned, and they're not required under the federal law. So that being said, we can go into our presentation. So I'm going to give you a little bit of backgrounds of what has been done with in regards to the balancing designs from the FHWA perspectives. So back in 2020, when we started this efforts, we decided to visit 7 lead states back then, and then talk to them and interview them about their efforts related to the balancing design. And obviously, COVID hit at that time. So instead of visiting those states, we ended up basically doing them virtually. Even we get some visits to the lab, virtual visits as well. It wasn't as good as the in-person visits, but still we were able to get out of those, enough informations where we developed 7 case study reports that are published on different websites, whether the NCAT, the NAPA, BMD, resource guys, or the University of Nevada-Reno websites. The barcode, the scan code, if you scan that one, it will take you directly. The QR code will take you directly to the FHWA websites, where you're going to see either by topic, the different publications, or you can see everything under the cooperative agreements. Now, the reports basically, and I really encourage you to go and look at those because it talks about the state's experience and their lessons learned, while implementing the balancing design. And obviously they are at different stages of the implementation, okay? One nice thing that you can find in those reports is a flow chart of their balanced mix design approach, how they approach it in terms of the starting with a lab mix design, into the verification, going into the productions. And it's basically a summary, right? Summarizing the specifications, 20, 30 pages. By the way, Texas is the longest tab for the balanced mix design, 40 pages into really a flow chart, just simplifying, just to give you an idea what it is. And out of it came basically an overall summary report and a tech brief. So what happened throughout that process, we identified tasks for the implementation of the balanced mix design. We came up with, I don't know, maybe like 12 tasks. And in parallel, NCAT were doing their NCHRP study. They came up with 16 tasks. And magically, we did the math, shuffled them, put them together, worked together, and then we ended up with 8 tasks, right? But multiple sub-tasks. So I think the content is still the same, but we summarize them or we shrink them into 8 tasks. And that's what really the tech brief is about. And those tasks are going to take you from early on, right, the why and the benefits and the motivation of the balanced mix design, all the way into your initial implementations. So if you look at the what are those tasks is basically, briefly summarized over here. The text brief talk more in details about them. But like I mentioned, the first task is basically the why and the motivation. Why are we moving into a balanced mix design, right? What's in it for all stakeholders, not only the agency, but the industry and everybody involved? Why is it now the time to go from a volumetric mix design into a balanced mix design? Now, when you go through that process and you identify the why, which is very important to get the upper management support, right? Because you're going to find out, if you read those tasks, that there are going to be some resources allocated for the implementation, right? We heard a lot through the geotechnical group about implementation and the variant, right? If you don't have the upper management support, it's going to be very hard to be successful with implementation. You're going to need staffing, you're going to need resources, you're going to need equipment, right? And you're going to need a champion. If you don't have the champions, basically there's no one to carry that flag and then walk you through the different tasks all the way into your initial implementations. Now, we call it initial implementation on purpose because there's no full implementations, right? We have to close the feedback. We have to realize that once we implement something, there's always room for improvements, right? So we learn from that process, and then we should always collect the information back and see how we can adjust and do things better. So those tasks, if you've seen them or they are listed over here, it's the same one that you see in the tech brief, the same one that you see in the NCHRP report from NCAT. They're very consistent, okay? And the report that developed by NCAT under the NCHRP study actually go even further in details into those 8 different tasks. On the right-hand side, you see like an example of the timeline, right? I don't want you to be scared. It shows around 7 years, right? We've seen anywhere between 5 years and maybe 10 or 12 years. Why? It depends where you start, right? Those that took them some time to get there, they even had to develop the tests, right? New tests, okay? And that will take also some time because you need to validate that test. One of the, some key elements of this we're going to talk about briefly later on, but one of them is the BMD test validations, right? Gaining that confidence in your test that you're going to select for the balanced mix design. So what next? We after we came up with those 8 tasks, and then we have our reporting and everything, we were able to basically put a workshop together about the implementation. And direct near plan, these contact informations, I think it's very clear over here, but I think you always say that there's only one near plant on the earth, on Earth, and direct near plan. So I think you can find it. You Google it, you can find it. But if you're interested in the workshop, it's really a very nice workshop because it goes over 2 days, but it's a half a day each day. But it goes through the different 8 tasks, and then it gives you examples from those different states, how they approach it. Now, does it apply to your state? Maybe not, maybe yes, because it depends on the state resources, organizations, and so forth, right? They are different. But it gives you some highlights, and it makes you think about what might apply to your case, and then take that as a lesson learned and implement that. We've done so far 14 virtual because we started that during the COVID. And then since travel was back on, we did 8 in person. I can tell you definitely the in-person one are way better, more interactive, enjoyable, and so forth. And you get a lot more discussion out of that. This is a map. The green is the virtual one completed. The purple are the ones completed in person. And the planned one, we have a couple upcoming in the next few months, and then we're planning even for more, into the early 2024. So if you are interested, you haven't had the chance, or even if you had it virtually and you want to have it in person, we're actually going back and revisiting some of those states because even we're updating our information. There's a lot that we learned since when we started this and nowadays. Now, out of that, like I said, we've recently, and that's something that Professor Amy F. Martin actually presented at the last TRB. And we were, oh, wow, that's pretty interesting. We should start collecting that data. So what she did, she took the 8 tasks, and then she mapped those tasks to the progress that's currently going on with the BMD implementation in Texas, right? What has been completed, that you see as a green, what is ongoing, what's in progress, and what kind of the completion date, if you want, or the timeline. So really very simple, concise, but actually based on the feedback that we heard, that was very good to see what are we lacking, where are we, and what are we lacking. Try to put your thoughts together and see, it seems like we haven't done any work. Maybe we should look into it a little bit further. And I think we shared a copy of that with the states. Hopefully you'll get to also fill in that and share that information back with us. We're trying to compile that, right, and update it on a yearly basis so that we can have a little bit of better idea of where the states are, right, at a little bit higher level. So what came after the workshops? Well, the regional peer exchanges. So if you see that we started with the state visits, we developed the tasks. From the task and the state visits, we came up with the workshop materials, and then we found that based on what we heard from the workshop, that there need to be some communications. We're lacking that communication. What's better than state peer exchanges? So we started doing those regional peer exchanges, and we've completed 5 of those peer exchanges. All 5 that are completed, they have a report, and these are the link. And again, you scan the QR code that will take you to the to those reports. So what's different about the peer exchanges is that we captured now what are the state challenges, all the lessons learned, and also what is the key takeaways. You know, we asked them at the end of the peer exchange. Now you're going back to your states. What you gonna do? What is something that you feel like you learned out of the peer exchange and you want to go back and implement, or at least explore, right, within your state? We still have one more scheduled for the Mid-Atlantic that's coming up in the fall, and that will kind of complete, you know, our regional peer exchanges, and then we're doing another lead state peer exchange, which is a little bit more focused. But what came out of those regional peer exchanges is really a list of critical challenges for the BMD implementation. So we compiled all that data together, and we came up with a list of challenges. You'll be surprised how many of those challenges are common among the states, okay? Now, when we looked at those challenges, we find out that, you know what? Some of those are more management related, and some of them are more technical related. Now, I understand we're all engineers, or mostly engineers here, right? We focus a lot on the technical, but once we put the states together and they start talking, and then this is not a technical problem, this is more a management problem, right? You're having some challenges in gaining the support. You're having, you know, how you're gonna quantify your risk, how you're gonna convince your upper management that your state is not carrying most of the risk, or you're balancing the risk, right, among all the different stakeholders. So the list of the managements are also summarized. So we have 6 management challenges, and on the other side, we also have 5 technical challenges. And what we find out, some of the challenges are really belongs to both, overarching one challenges, and that's what we need in the middle. So if you think about the technical, right, probably can relate easily, right? What are those challenges? The BMD test validations. How can I trust that test, right? How am I comfortable in selecting test X versus test Y, and so forth? Or what are the testing procedures that involved? Or what is the variability? Am I comfortable with that variability? How can I control it? I need to understand that variability, and so forth. So these are the basically your technical challenges. But on the management side, then you start talking about the change management challenge, right? How are we gonna instill that culture that, hey, it's time to do that change, right? We need to do better. Can we do better? And why we need to do, we need to move into that change. And what's gonna cost it? Because a lot of the time what we heard, oh, we're gonna change it, it's gonna cost more, all right? So again, funding is the reality, and we need to keep that in mind. So I want you to keep in mind that not all these challenges were experienced by all states, right? And also, some of those states identified, once they identified those challenges, they have a solution in place, or they're working toward the solution. Okay, so keep in mind that there are some lessons that can be learned from those states. But also, interestingly enough, is what we heard from the states, also we heard from the contractor. So they're not far apart, right? So if the state is struggling with technicians or resources, right? You can hear that same thing or same argument from the contractor side, and so forth. So there is a lot of common challenges, which means communication is important among the different stakeholders. And what we learned is sitting in early on into the process and then talking to each other and get everybody involved early on in the process will help the implementation and then or the likelihood of the implementation to be more successful. So with that, recently, back in March, there was also another peer exchange as part of the Accelerated Implementation and Deployment of Pavement Technologies program. It's a pool fund program. And the states that were participating based on the balance mix design came all together, so 15 different states, and met at the NCAP facility. Now, the purpose of that peer exchange was a little bit different than the regional peer exchanges, because the regional one led to the identification of the challenges. In this one, it was, here are the challenges. Let's talk about the solutions. Tell us how you did it. What can you share with other states so that can be documented, right? I think the key is basically to document the information so others can refer back to it. And sometimes when you do that documentation, it's going to help you as well with your upper management. You can go back to your upper management and say, there you go, I have a document that shows that was successful, or this is the path that was taken by that state and led into success. So prior to the meeting, we asked them, these are the challenges, rank them. Okay, every time you see red, that means that's their first choice. You see the blue, the dark blue on the other side, the least choice. So the one that stood out basically out of that from the technical management, the top two were related to the test validation of the BMD and the testing procedures and protocols. And I'll talk a little bit about what are those. And then on the management side, it's a cost benefit analysis, which means the why, right? Shows your upper management why it is cost effective if you want, and specifications and risk management. And the overarching one was more about the education, training, and communications among the different stakeholders. So I'm going to talk, given the limitation, just about three of them: the test validations, the testing procedure and protocol, and the cost benefit analysis. So what is the BMD test validation? So test validation means that your tests correlate with the field performance. So in other words, before I implement my balance mix design test, I want to make sure that the test is telling me what's supposed to tell me in terms of field performance. There's a strong correlation. That is going to require some test sections, right? I think we're going to hear today from North Dakota, right? There you go. They're, you know, they have a current effort. They put some time into it, they establish the plan, and they're doing some test sections to correlate their lab tests into their field performance. Because you need to gain that confidence in the test, okay, as an agency, as well as a contractor, okay? Now, there is a very good documentation that came out of the Capri program that NCAP put together, which is a guideline and recommendations for field validations of test criteria of balanced mixture design. Because if you have a good, strong correlation, if your BMD test in the field performance, then you can support your selection of the test criteria, right? You'll have the proper justifications and the support of what that criteria should be. You know, throughout that process, though, you have to keep in mind that you need to basically consider the variability as well. Okay. The other aspects would be basically the testing procedures and protocols. So a lot of the time when you refer to the AASHTO or ASTM, where do you end up? Where typically it is, you know, how to run the tests, right? And then just what to report. But a lot of the time, it doesn't describe how you need to handle your materials. What are your conditioning? Okay. What happens when I receive that material? How long can I wait before I compact the specimens? Is that okay or not? Or once I compact my specimens, can I leave them, you know, sitting in the lab for a week, 2 weeks, a month before I test? Or I need to put a limit. So those little details. Now, in the past, right, with the volumetrics and all of that, maybe those were not that important because our volumetric properties were not very sensitive to those changes. But now with the BMD tests, some of those, mechanical tests might be sensitive. How long are you going to keep that specimen, sitting on the shelf before you test it? Okay, so that's going to help the results. So you need, as part of that implementation process, to establish those protocols, all the handling, conditioning protocols. And then the last one, which is from the management perspective, which is the cost benefit analysis. The graph didn't turn out the way it's supposed to be. This is your cost. Well, all right, so what that graph is supposed to tell you, this is the percent of the system lane-wise. And then it is in deficient, which is the red, and the green is in the good condition. And that's supposed to go over a 15 years period, okay, up to 2022. This is graph coming from New Jersey DOT. So back in 2007, they implemented what they call those specialty mixtures. I think we heard earlier this morning about the HEPTO, high performance thin overlay, the HRAP, the high wrap mix, and then it goes on the brick, the brim, and wherever. It's hard to keep up with the terminology. But those are really specialty mixtures designed specifically for a given application, whether it's a thin overlay, whether it's a medium layer, or like a crack attenuating layers, and so forth. They're balanced mix design, right? They're balancing rotting and cracking or durability. When they implemented those mixes, they had about 49% of their system deficient. With time, after 15 years, that dropped to 19%, and now they moved from 50% good to 47% in good condition. That's a significant change. And just for the record, those specialty mixtures are only 20% of their overall asphalt tonnage. So they don't apply them, throughout their entire program. Now, couple lessons here that at least my staff I learned. First, it works, right? You can see it, and there is improvement. It has impact. But you gotta be patient. Unfortunately, here it's not showing very well, but if you look at the red on the top, the first 4 or 5 years, we didn't see much improvement. Okay, so we don't want you to be disappointed, right? It's gonna take time to see the impact. Okay, and then this is where it becomes a little bit tricky because your management is not gonna wait 4 or 5 years. Or you don't want to delay the implementation 5 or 6 years. You want something with a quicker turnaround. All right, so that's why it's a challenge. How can I demonstrate that within a reasonable amount of time? Now, during that AIDPT pool fund study, Randy West out of NCAT presented very nice data for an experiment from their test track, where back in 2018, they had multiple sections, one that is designed based on the volumetrics, the typical traditional volumetrics design, and another one using the balanced mix design. And that was a mill and inlay, 2.5-inch mill and inlay as part of one of the Texas experiments. If you look at your volumetric design, the asphalt binder content was 4.7%. Look at your balanced mix design, obviously it is much higher, right? It's about 8 tenths higher on the asphalt binder content. And I'm going to show you the performance that Randy presented from their track. Then back in 2021, they thought, well, this is maybe a little bit high, right? Can we optimize that mix, right, to make it a little bit more economic? So they came up with another balanced mix design, and the binder content was around 5.3. Now, if you notice, the wrap to binder ratio is constant, okay? Which means you're adjusting the asphalt binder, that you must be doing some adjustment to the gradations. And this is another thing that we learned throughout those workshops and talking to the different agencies and contractors, that gradation now also plays a major role. You can make adjustments to your gradations to meet your balanced mix design. So if you're wondering about the performance, what you're seeing here on the left-hand side is basically the test results in terms of the crack propagation rate from the overlay test versus the hammer retract rod depths. The green is where you would like to be. The volumetric design is basically passing the rutting but fading the cracking, right? The 2018 balance mix design is sitting somewhere here nicely where it passed both the hammer and the cracking. And this is kind of you want to redesign, the re-engineer. It's basically pushing a little bit to the borderline where you still have a good rutting and it's just a borderline acceptable crack propagation rate. You look at the performance on the right-hand side. The blue is the volumetric, which basically starts cracking about 5 million needles. And then the dark orange is basically your 2018 balance mix design with the high binder count, 5.5%. The light orange or the yellow, it still hasn't cracked because remember, this is not as old as the other one. It was built in 2020, right? So it still hasn't cracked at a 5.3% binder count. So first of all, it seems like it's working, right? It can work. Balance mix design can help you improve the performance. The second thing, if you look at the volumetric, the propagation rate is faster than what you see on the balance mix design. But somehow, like the validation of the crack propagation rate parameters from the overlay test. Very nice. So that's only from the overall FHWA efforts. I'm going to talk a little bit more now on the West. I picked, 3 states, obviously Nevada, coming from Reno, Nevada, and then California and Oregon, again, to give you a little bit of update on the California side, and then Raghu is here. You can correct me if I'm wrong, right? So what happens is they establish a working group with the different stakeholders. So I think this is one of the most important tasks. Right? My advice to you, if you want to start the implementation, put a working group together and involve all the stakeholders. The earlier, the better. Okay? Because then we can start getting the feedback early on, and then everybody, get the opportunity to listen, hear, provide comments and inputs to the process. And then they developed a scoping document that entailed 3 phases: general review, the testing and evaluations, and an implementation phase. Now, part of that testing and evaluations, they kind of set a midterm age. So with the cracking, the challenge is the age, right? What happens if you test your mixtures after short-term aging, you may get a certain ranking. If you apply a long-term aging, that ranking might switch, right? Because of the absorption of the binders, because of the aging, susceptibility of the binders, and so forth, you may get a different performance. However, from the implementation point of view, especially if you're doing acceptance for production and so forth, you cannot wait 3, 4, or 5 days to get the results. So you want something that is, we call it accelerated, if you want, accelerated long-term aging, quick enough that allows you within 24 hours to get the results. So they came with a 20-hour and 100-degree C. It's actually realistic, practical, because you can put it in the oven today, come back the next day morning, pull it out, and then test your samples. And also, it's somehow consistent if you think about the PAV on the asphalt binder. Typically, that's what we do, right? We age the binder for 20 hours at 100 or 110 degrees C, depending on the locations. So it's not really, an excessive aging, but it's aging enough to give you some results. And then the next step seems that looking into some validation of their rutting and reflective cracking under their heavy vehicle simulator. Now, I need to mention that early on, especially that was part of their long life projects, because they required a lot of testing for cracking and rutting and so forth. The UCPRC, University of California Pavement Research Center, they came up with a systematic way to adjust the asphalt mixtures. So, because always the key is, once you get into a balance study, you're doing volumetrics, right? You need more asphalt binder, you add asphalt binder, right? You need less, you put less asphalt binder. Well, you need more CT index, what do you do? Right? Or you want to improve the rutting. So there is basically a flow chart that they put together where It depends on the starting point. If you have a rutting challenge, you go one side. If you have a fatigue or cracking challenge, you go to the other side. Now, there are changes when you apply those changes, right? Like the green ones, the green boxes, they can help you both on the rutting and the fatigue side. But there are other changes like the blue one, if you do those, it will be good for fatigue, but not necessarily for rutting. And then the brown one's the other way around. It may be good for rutting, but not necessarily for fatigue. And again, you have to balance that. That doesn't mean this is the only way, but this is one way that you can, look at it in terms of, just get an idea of what kind of changes can be made to have a passing mix design. We also ask the contractors when we're doing those site visits from contractors, like, how did you achieve your passing mixture? What did you do as a change? And here's the list of things that they tried or they implemented. One of them is the binding. Yes, you can ask for a 6422, but guess what? It depends on the source of the binder and the formulation of the binder. You may get different performance when it comes to the asphalt mixtures. Yeah. The key aspect was because they were failing cracking test that was done at intermediate temperatures, what they found out is that intermediate temperature criteria. How far are they from that criteria? So two binders, one that is passing significantly that intermediate temperature versus the other one was barely passing. It made a big difference on the mixture testing. So the asphalt binder source, adding, maybe more binder to your mix, excluding or minimizing the use of natural sand, okay? Change in the gradation, change in the way that you can have not necessarily the gradation itself, it's more the stockpiles, so that you can have more effective binder rather than total binder. And then improve the aggregate structures to increase your VMA, and then understand some of the differences in the aggregate gradation between the cold feed and the post-plant gradation, because some of those aggregates may end up some breakdown when they go through the plant and generate some dust. And then with additional dust, that may lead to cracking problems. If you are interested in learning more about the changes and what kind of changes can be made, there's a very nice document, tech brief, that's available part of the FHWA co-op with the Jurado, that where we ended up interviewing 7 personnel from the industry with vast experience with mixed designs, and they gave us a lot of tricks on how to make changes. And we kind of documented those changes in the tech brief. Now moving on to, oh wow, into Oregon. So Oregon are lost. They don't know what they're doing. But basically, I'll try to summarize that. They started about in 2018, right? So about 6-7 years ago, they looked into the test, they selected their test. Looks like they're moving the cameras directed test and the USCT. They've done some pilot projects. And then, well, before the pilot project, they did ruggedness testing. They went ahead and did some ruggedness testing and round robin testing. And then they did pilot projects. So they had the test sections with the BMD and volumetric mix design, but they're still relatively young. They're monitoring the performance. So far, they're mixed good. They're about 2 or 3 years out of that performance. No rutting observed, but it's still early for any cracking. And their plan is to have additional full-scale testing with their balanced mix design mixtures. Some of the observations is basically also they see increase in the binder content, okay? And then their CT index increased by about 1.23 times. Now, I wanted to just pause a moment here about the increase in the binder content, because always, increasing the binder content is anticipated to give you a better cracking resistance. Now, this is true starting with a dry mix, right? But if you have already a decent, I don't want to say rich, but enough binder, what we've observed with other states or other contractors was really a change in their gradations, certain type of stockpiles, the binder source. So they have to tackle other things, right? So there's a lot more into balanced mix design than just, we'll add another 0.5% or 1% of asphalt binder, right? I just want to make sure. That's why that tech brief is important. If you want to go through it, you'll see what are those different changes. And then wrapping up with Nevada. So Nevada is still the beam state. So use the beam mix design. It's done internally. It does require the beam stability. They are in the early stages of exploring the balanced mix design. However, a few years, about 10 years ago, they started research related to the engineered stress to the inputs. So they typically use a type 3 mix, which is a fine mix, under their overlay. And then the cracks will reflect really within a year or two. So then we did some work to look into whether we can engineer that mix by using rutting tests and then using some cracking tests, like the overlay test and then fatigue flexural bending fatigue test. They did pilot projects in the different districts, and then they did the full projects, and now actually it's another basically mix in their matrix. Okay, and they're using it now on a regular basis whenever they're doing overlays. If you are basically wondering what the spec looks like, this is basically a summary of the mix design specifications. One thing I would like to highlight that those mixes are fine mixes, but are also designed for low airports. 0.5 to 2.5% airport. So they're very rich, right? That's why there is a stability test to make sure that they're still stable under equipment constructions and under traffic. And it's been successful. So this is a picture over here. This is the core for the field. This is what the ESRC looks like. The engineered stress for each course looks like. This is what the type 2, it's a half-inch non-maximum migrate size mix. This is the overlay mix. And the one on the top, the B, this is the open graded friction force. Now, the overlay test results, just to put things in perspective, this is where the designated typical mix, number of cycles, hundreds. This is what they used to have, the type 3 final mix, underneath the type 2, from 700. This is where the ESRC is exceeding the 5,000 number of cycles. The light and the dark colors, these are the field produced mix and the force. The force were collected and also tested from the field. And they kind of, tracked very well between the two. Now, I want to show you also a little bit about their balanced mix design efforts to they do handle feedback and development purposes, informational purposes, but not necessarily as far as they forgot. And they're exploring about the CT index values, and they start collecting material from a different, location within the states. Why the concern with the ductility is because what we've observed, there's a lab mix design, there's a job mix formula, and there's a production. During productions, we're seeing that the dust proportions going up. Okay, now some of it might be because of maybe a backhouse fine returns, and some of it is if you're trying to target a certain volumetrics, right? You can ride on the low end of your asphalt binder spec and fill in those voids with dust. Okay, then what's going to happen? Then your durability will get affected. So in this work, we got both the lab, the plant reuse, and then we redid the lab, but a different dust to binder ratio. Also to see what would be the impact of the BP on the results. What I'm gonna show you here quickly is some of the trends. These are statistical trends. I don't want you to take them that this is the relationship and what's the equation. This is statistical analysis to show between the ideal CT. So the vertical line is always the ideal CT, your CT index, versus the different parameters. So for instance, this is the ideal CT versus dust proportion. Ideal CT versus the effective binder, versus the asphalt film thickness, the total binder, the BMA, and the void filled with asphalt. These are the ones that showed highly statistical correlation. So all of them, if you look at the p-values, way less than 0.05 parameters. So what that tells you, if you look at it a little bit, with the higher dust proportion, you have a trend of decreasing CT index. There's a likelihood that your CT value is going to go down. And then consistently, whether you add the effective binding or the asphalt film thickness, the total binding, or your VMA, or your VFA, which some of those are interrelated, right? You see that that will improve your CT value. So it kind of proved the concern that the state had with the higher DP and riding on the low end, right, of your binding count. Remember, you set a target 5%, let's say plus or minus 0.5%. You can always get 4.5, 4.6, and still pass. When you're gonna fail, if you have a PWL spec, right, that might fail. But if you don't have a PWL specs, there's a tendency that you're gonna have more fine in your mix and then durability problem. And then also we looked at some relationship between the CT and the overlay test. And then it shows you, because the reason for that is whether the ESRC can be done instead of the overlay test also can be done with the CT value. I think with that, I will conclude with some closing remarks. That was supposed to be just a thought about the different stages of your mix. You start by developing the mix design in the lab. You approve the job mix formula. You develop your quality control plan. You start your initial productions, and then you move to the full productions. Nowadays, with the balanced mix design, I think we are okay up to C. We're still working out D, which is our initial production. But I think we're comfortable with more doing the mix design in the lab, approving the job mix. The initial production is going to become very critical with the balanced mix design. Some states don't require a test strip or a hot drop, right? So with the balanced mix design, we're seeing more and more that this is critical, this is important. Or you did the okay for full production, want to make sure now your plant produce mix meet your balance. And then the biggest challenges that we yet need to work on is during production. How can we accept those mixes? Right now, we have our acceptance body characteristics, which are based on body metrics, gradations, and so forth. What are we going to do if we have some BMD tests? Can I use them? What is the frequency of testing? What's the turnaround time? Right? And if I do so, can I relax some of the other acceptance body characteristics? Okay, so that's basically what this is supposed to show you. So thank you. I think, the BMD brings challenges, which is we should take this as an opportunity for growth. And then these challenges might allow us basically, as we work through those, it's an opportunity for a change, not only for improving our asphalt pavement, but also it will open up the door for innovation and sustainability.
Thank you.
Great presentation, Elie. That's kind of sets the stage now for the next phase here, where we bring in the presenters from the various states. And so the first one will be Erik Lyngdal from the Wisconsin DOT. He's a state materials engineer there. So please welcome Erik.
All right, thank you. So yeah, I'm going to go a little bit over Wisconsin's experience here. Sorry, just verify. Okay, yep. All right, so we've been working on implementation of balanced mix design for feels like a decade now. And it's just been an accumulation of a lot of research investment in different areas. So we just stole that table that Elie had showed before from Texas and just filled it out ourselves to kind of give you a snapshot of where WSDOT is at. We've picked our tests. We've come up with an aging procedure. We've also implemented regress air voids. We've got equipment at the central lab, but we don't have it at the regional labs. We've started some interlaboratory studies that are in progress. We've baselined all of our mixes. We got about 300 different mix designs tested, different types. You could say it's in progress, but I'd say it's closer to complete. We got some test sections out there, State Highway 69 south of Madison. We have done some shadow projects, and I'll show you some of that information more in detail in a couple slides here. We've already done some pilots following the balanced mix design A method, so we just added our performance tests onto what our current specifications are for mix designs. And then we have a lot left to do in terms of bringing it then to the regional laboratories and then try and go to quality assurance on a project level. So I see that as the next barrier for us to overcome. So I just a couple of details of some of the stuff we've already completed. We're going with Ideal CT and Hamburg Wheel Tracker. So just give you a second so you can see exactly, what our testing protocols are going to be for these. I know that aging procedures are a matter of dispute, but we've kind of made up our mind and we're going to stick to it. And then after this, I'm just going to go into a couple of recent research projects that we've completed and highlight some of the barriers for implementation that have kind of come out of those more recent research projects. So the first one I want to show you is those test sections on State Highway 69, just south of Madison. You can see the plan and where all the test sections are located up on the upper right corner there. It's kind of hard to see, but we tried to find using the FWD where an equivalent foundation was along the project, because they had all different materials under there. There was just like a concrete, virgin-based, combinations of both. So we took the FWD out there and we tried and find an equivalent foundation to build the surface layers on. So we could, assume that the stress that they showed is related to the surface layer and not differences in the foundation, right? And then we put in the special provision that 6 different test sections were to be constructed in different quadrants of the BMD, performance characteristics, right? Rutting susceptible, cracking, cracking resistant, cracking susceptible, rutting susceptible, high performer, and so on. And then we also took a couple of those mixes and then we just added polymer modified binder in their place. So that way you can see the impacts of polymer modification in conjunction with the balanced mix design concept. And then the barrier I see from the research, so you can see on this lower lower left-hand corner here, you can see we kind of hit the quadrants in design. We did our best. And then these dotted lines here, as you move into the field, you can see they moved. So mixed design, then to the field production, the measured result changed. So that means we got to deal with differences from the lab going into the field. So that's one barrier that we need to overcome. And then as part of that same project, we did shadowing. So to get a feel for production variability, so you got sampling variability, you got testing variability, and then you got production variability. So we tried to isolate production variability, right? So the things, I want to point out a couple of statistics just so we can move on. So you can see we sampled from lots on multiple projects. So you can see there's 10 projects and we sampled from 3 lots so that you can get a coefficient of variation, a representation of production variability for multiple projects. So I want to point out the mean coefficient of variation for Ideal CT was 13%. And then over here, you can see the mean coefficient of variation for airvoids is 10%. So to me, this is a great success from this project because that means the production variability of CT index is somewhat equivalent to that of airvoids, which means we can control it at the plant level, right? So that's a huge success from this. That is not the case between labs. So that was one lab. So now we're looking at interlaboratory variability, which is not ideal right now. No pun intended. So here's the Hamburg wheel tracker. You can see the spread. So one lab had a corrected rut depth of 5 and the other lab, you know, can go, had a corrected drop depth over 10. That's not good. Same thing with the CT index. So here's a long-term critically aged over on this corner. So you can see somebody can measure in one lab a 30 to roughly a 70, 80. That's not good. So we need to focus our energy this summer. Our energy is getting focused on this problem right here. So we're working with our contracting industry. I think we're gonna go out and do a bunch of splits, a bunch of round robins, get some of the engineers out of the room and let the testers tell us how to get rid of that interlaboratory variability. And then hopefully we can come up with a nice procedure that all of our technicians can get on board with and feel comfortable that they can match each other's laboratory. So there you go. So there's a lot more work that's gone into it, but I gave you the quick and dirty and where we're at right now. So thank you.
So next up is Jacob Graessle from, so he's a field materials engineer for Missouri DOT.
All right, so I'm going to start out talking about just kind of a little bit of the history. Briefly, 2017, 2019, we started looking at what test methods we wanted to do. 2020, we started looking at validating, and then we went right into some pilot projects. Right away, we kind of decided that we don't want to, we kind of wanted to focus on plant produced specimens and not look at reheating as much. So we're doing plant produced specimens as well as the long-term aging just for information only, but we're currently working on specs that are incorporating balance mix design into our super pave spec, combining them. So we decided on the ideal RT rutting and the ideal CT for cracking, and keeping our TSR, of course, for stripping. Our goals for this specification revisions of our super pave spec was to first increase our performance of the pavement, as well as fabricate the pucks immediately after to test the pucks immediately after fabricating them, to try to reduce the variability in aging. So we determined that we're sampling them and then allowing the mix to age just for a short amount of time to allow the reactants to take effect, such as the warm mix additives, for 30 minutes. Otherwise, we found that could create some false rutting test. And then the third goal was to reduce worker exposure to traffic. So that was our other reason for choosing to sample at the plant versus getting our loose mix sample from the roadway, which we were doing previously. All right, so here's our pay factor incentives breakdown. We have 3% total for our volumetrics, which we are still keeping volumetric requirements, but allowing them to be a little bit looser with density, air voids, and AC content, all in PWL. And then we have the CT, and the TSR has its own 3%, and that is not going to be PWL. And then we're also including a PMTP spec, since that we are sampling at the plant. So we are wanting to make sure we're not getting segregation on the roadway, and then our smoothness incentives stay the same at 3 to 5%. And so for this specification revision, we wanted to keep with the same that we have now to allow contractors to be able to choose this spec if they want to versus the other one. So we're doing several approaches for implementing, and I'll kind of go over that more later. But for our CT and PSR, we looked at our validations and came up with some ranges for our incentives and disincentives. And we made this first to as PDL, thinking that we're going to do PDL with CT, but because of the variability, we chose not to do CT. So we wanted to allow the contractors to get a bonus for anything greater than 100, but also it still requires the 85% or greater for the TSR. And then the RT is only a qualifier, so they just need to meet that minimum. We recently have just started implementing the RT index. It's pretty new to us, so we are allowing, if there's any question if the RT is valid or not, to do the Hamburg as a verification. So here's the hardest part of making this spec was how are we going to do all this testing with the volumetric testing as well. So we looked at doing our lot size at 6,000 tons with performance test twice per lot at 1,000 or 3,000, 1 per 3,000 tons. And then our TSR is at 1 per 12,000 or 1 per 2 lots with density cores at 4 per lot, and volumetrics is 4 per lot at a minimum, which they could do more if they choose to. And so initially we wanted to try to get performance testing done once per day. We thought that would be ideal, but it was a little bit difficult to try to do that with volumetric testing. So we went back from once per day to a tonnage and decided on 3,000 tons, which is thinking kind of more 1 to 2 days. Contractors are probably gonna on a good day get about 2,000 tons done, at least in Missouri. So we're hoping that this isn't gonna overload them too much. We've been in good communication with our contractors about what they expect that they can do and what they are thinking that they can't do. And we kind of come into agreement on this. They think that it's pretty aggressive, but we're gonna have some pilot projects and see how it goes. So for our specimens, we're doing 5 pucks for the CT, 3 pucks for the RT, then three boxes of loose mix for the Hamburg, just in case we don't agree upon the RT index, or we're thinking that we're getting a false value for that. And then of course the performance pucks will have a short 30-minute conditioning after or before they're molded. They'll have a 30-minute conditioning as a loose mix, and then they will be molded and tested immediately after molding once they cool down. So how we're planning to implement, or how we're starting these pilot projects, is we're allowing the contractors to first choose if they want to do this new spec revision or the current spec that's for super pave now at the time of bidding. We're hoping some contractors are on board with this and will choose to do it. It's pretty hopeful on our part, but we're also going to be doing probably 10 to 15 pilot projects per year, requiring this as a JSP. Hopefully after a couple of years of doing this, we'll feel comfortable enough to implement it full scale, though we're have pretty high hopes that we'll be able to get a good feel after a couple pilot projects or a couple of years of pilot projects, make some corrections, and then implement it full scale.
Jacob. Higher CT next. Next up is Metcalfe from the Department of Transportation. He's the state materials engineer.
Welcome. Thank you, Kurt. Hello, everybody. Like I said, over Metcalfe MDT, and I'll try and go through this quickly. We don't really have a whole lot of data here, but so we'd like to think that we're somewhat progressive in that we've been doing half of a balanced mix design for at least 20 years. We've had the Hamburg wheel tracker as a mixture verification test and a field no-go test. Like I said, for at least the last 20 years. And we've been waiting for the cracking test to come along as a bookend. And so when the national effort started, we're happily riding on the coattails, but we're still a little bit behind. So, like I said, we're one of 6 states, or excuse me, one of 16 states doing the Hamburg. Like I said, we had it as a part of our mix design verification and then a go, no-go test. I'd like to think that I started this. I don't know if this is true, but I know that Montana was one of the first states to vary the test temperature based on high PG because we were doing lots of grade bumping, and in order to really evaluate the effect of the polymer, started to test the material relative to the PG grading test, but that's our current spec there. These are the other states doing the Hamburg, just for some comparison. And if you're one of those states and you don't know already, there are some round robins out there in the Hamburg through NCAT, and the state of Utah does some round robins. And I've been working with AASHTO Resource to stand up a proficiency sample program for AASHTO T324. So we're working on that right now. So steps to implementation in the Treasure State, what we've got accomplished. We've realized the benefits and want to move forward. Like I said, we've been looking for that bookend to the Hamburg for the permanent deformation performance test. We've tried to give our contractors the ability to innovate with their designs as far as like gradation, asphalt content, those kinds of things. And what we started up in our specification many years ago was meet a target within our range, or we're going to give you the acceptable range of volumetric targets. You pick a target that's in that range, and then you try and achieve your target instead of trying to hit the mid-range to try and promote consistency. And we'll control it with our performance test with the Hamburg. You make a change, you want to make a 50% bid split, fine, we're going to run a Hamburg on it to make sure that it's still going to hold up. You want to make an asphalt content change, fine. We're going to run Hamburg to make sure that there's no added instability to the mix. So we're basically following the process for implementation outlined in the Capri documents for those that are familiar, the steps to implement. We've decided on our aging procedure. We're going to go with the Wisconsin procedure. We got the Hamburg, and we're in the process now of correlating the ideal RT to the Hamburg. And then we originally decided on the CT, and as has been discussed, those correlations aren't as prevalent as the Hamburgs are. But if you're looking at comparing the Hamburg to the RT, like I heard some folks talk today, there's a very good correlation. The work that they did in Texas, Amy Epps Martin, we've been able to somewhat replicate that. I was chatting with Elie earlier today. Our squared values are in between 6 and 9.6 and 0.9 already. So we're doing pretty good there. So in progress, we've got to establish the baseline. We only have maybe 100 data points. I'd like to get at least 500 data points. That's the one thing that I see as a whole, and some of the research out there is, we make correlations based on 4 or 5 data points. Well, we need more data. So we're collecting data, and we've got the staff, we've got the basis of a good correlation to the RT and the Hamburg. And so now we've started our outreach, and that was actually earlier than planned. As you've probably seen, you know, the timeline involved for implementing balanced mixed design, if you're starting from scratch, is not tomorrow. Derek goes around telling everybody that the best day to start was yesterday, and the next best day is today. So I knew that it was going to take a while. And I wanted to collect all of this data because I'm not sure what your experience is in your states, but whenever we try and implement something new, the contracting community comes to us because they don't like change. It's like, where's the data? Where's the data telling me that you need to make this change? So I wanted to have a good base of data. But because we've been using the Hamburg and there were a couple of projects that went south on us last year, our contractors were concerned and we had a meeting. I mentioned that this was part of our balanced mix design and there was a workshop. So they said, well, we need that workshop now. I said, well, I wasn't going to bring it to you for another year, but since you asked, so we're hopefully going to have one in this winter. And then since we are a cold weather state, we're starting now to lean towards the DCT. And if that is going to be a better test. My pipe dream is that the DCT and the CT can somehow have a correlation. I don't really know if that's going to happen, but we haven't got that far yet. So that we could do, again, this is my pipe dream, RT in the field, Hamburg in the lab, CT in the field, DCT in the lab. So we're working on that. Where am I at here? So moving forward, we've got to do the field validation. We haven't done any, we haven't done any pilot projects. We don't have test sections. We don't have shadow specs. We don't have any of that stuff yet. So we're still validating, continuing our outreach. Have to work on our specifications to see how they're going to fit in, quality assurance questions that are out there. How are we going to implement this as far, if you want to put it into one of the 4 buckets, what approach are we going to land on? I mean, I'm looking more towards the C approach. How to incentivize it, how to deal with sampling, all those types of things. Lots of people have already talked about this. And then, of course, the final review and the buy-in with our contractors. And this is just a nifty little thing here. So I don't know if you caught that at the beginning, Josh Heck, for those of you that know Josh. If you've seen me travel around, I've been recruiting for a bituminous specialist. Well, we got Josh and now he left. So he got stolen by a private contractor. So if anybody's out there looking for a job, wants to come to Montana and be a bituminous specialist, give me a call. And that's the end. And thank you very much.
Thank you. Great information. Next up is Aaron Perez. He's a pavement section team leader at Materials and Research at Dakota DOT. So,
thanks, Kurt. Oh. There you go. Hey, everyone. So I'm Aaron Perez, work for the NDDOT. Here to give you an update where we're at with balanced mix design, but I mostly want to talk to you about what we're going to be doing this summer, building a validation test section. So the first thing you do when you want to start something new, it seems like you join a pooled fund, right? So that's what we did. I'll skip a little information here about the pooled fund, I suppose. But the biggest thing about it is I got us partnered with NCAT. They've been super helpful with us putting together plans. And we've also been involved outside of this too. I mean, Dr. Elie Hajj, you've been up to North Dakota. You came during the best time of year, right? During our record snow year. So we joined this pooled fund. And this has been very helpful to us building these balanced mix design test sections and hopefully to help develop some specifications and implement some pilot projects going forward. So when we were trying to pick a project for the validation, we were kind of left with, well, what do we got to work with here? We didn't really want to do just a regular overlay project. We are a cold weather state. Thermal cracking is a real deal. And we didn't really want something that would be reflecting through because that just seems to not really make it even past 1 year. So we actually picked, I was close to Bismarck, luckily. We have a cement treated FDR with widening job. This is going to be 4 inches of hot mix asphalt on 10 inches of cement treated base. So as Dr. Elie Hajj said, one of the first steps we did with this was put together a stakeholder team. This was very beneficial. I won't go through the whole list here, but we got a good combination of contractors, industry, state, different associations, and FHWA. So we went into these stakeholder meetings. They're very, very beneficial in the sense that we had an idea of what we thought we wanted and came out of it figuring with a totally different plan of what we were going to do. So here were some of the things that were brought up. Contractors asked for 1,500 to 2,000 tons production before changing the mix. We were thinking less. Keep the variables to a minimum. That's we all like, and no matter what we do here in transportation. So in North Dakota, we run portable plants. We typically only have 1 main liquid asphalt tank, and crushing extra material to account for mix design variations would also cost money. So where we landed was with 8 test sections. Each was going to be 2 miles in length. We're going to be running with 2 different binder types, which are both really prevalent in North Dakota. So what we're going to be doing, just for simplicity's sake, is we're just going to be varying our asphalt content. You would kind of mention that a little bit too. It seems to be a very easy way. More asphalt or more AC content, you're going to have better cracking resistance, but you're also going to be rutting potentially. So we actually set some different levels here, 5.5, 6, 6.5. But we do have it in the plan notes for this project where we're going to do some testing initially and see if we can adjust that because mixes are sensitive to different AC binder percentages. And we're also going to have 2 sections that have wrap with the 2 different binder types. And for simplicity's sake, we're keeping the aggregate gradation the same throughout. And we're only doing this on the top lifts. We've got 4 total inches. The bottom 2 inches are going to be paved the same throughout. And then we'll just have the test sections on top that will be varying. So this project was bid in February 2024. We're going to be constructing it this summer, and it was about a $20 million project. And we're super excited for it. I know I am. I'm going to be out there quite a bit this year. So this kind of gives a rundown of where we've been. So step 1 for us was benchmarking our current mixes. And we did that in 2022 and 2023. In 22 was our first real year. We just grabbed about 30 different projects, samples from the road, and put them through the ideal CT, the Hamburg, and the DCT. And then in 23, we ended up taking 8 different projects, 1 from each of our 8 districts. And we took 3 samples on each project, 1 at the beginning, middle, and end of production, just to see variability within the jobs. And then we also, at that point, got the ideal RT jig to go with our ideal CTs. So we've been looking at that for some sort of correlations too, hopefully with the Hamburg. So step 2 is currently where we are at now with building some field validation projects. And so it's to be on a Highway 14 job this year. After this, we're hoping to get to shadow projects and develop specifications, run some pilot projects, and at some point get to full implementation. And here's just some extra info we wanted to throw in here too about something we're already kind of seeing with the Hamburg. We thought we really didn't have a stripping problem in North Dakota. We actually, through the Hamburg, just from benchmarking our mixes here, we actually identified an area in North Dakota that had a stripping issue. And this was actually pretty neat to see because the Hamburg identified it, and then we were able to test different anti-strip or liquid anti-strips that the mix designer was able to use. And he actually had his own version of a Hamburg and tested all these different or liquid anti-strips. And then we actually change ordered 1 onto a project, and we're really hoping that we'll see that road last a heck of a lot longer than it would have if we wouldn't have had this Hamburg. So we're already seeing some of the things that these things offer. And I guess we'll save questions for the end. Thank you.
So we have 1 more here, Ian Gilhooly from Materials Engineer from Illinois.
Thank you.
Hey everyone, my name is Ian Gilhooly. I'm a materials investigation engineer with the Central Bureau of Materials at IDOT. I'll continue our discussion here on balanced mix design. So IDOT uses a combination of performance tests to evaluate mixtures. The state chose two specific tests, rutting and cracking, to assess rutting and cracking performance, the Hamburg and the iFit. The state bought 10 devices back in 2010, and in 2011, the department met with Texas DOT for a tech transfer meeting to help exchange knowledge about the device. Later that same year, we started testing higher asphalt binder replacement and warm mix asphalt mixtures. And in mid-2012, the Hamburg was required for new mix designs and renewals. In late 2012, the department began their uniformity studies, and which we conduct on an annual basis, similar to our annual volumetric uniformity studies. And by 2014, we fully implemented the Hamburg wheel tracking test in mix design and reduction. With the implementation of the Hamburg, rapid RAS usage increased, and the ABR in these asphalt mixtures greatly enhanced the mixture's rutting performance. However, increasing ABR can also increase the stiffness of the mixture and can result in a more brittle material. So IDOT and the Illinois Center for Transportation began research to identify a test method to measure brittleness in these mixtures, which brings us to our iFit test. The next phase of the state's performance testing took quite some time to fully implement because the test method needed to be developed first, and enough data needed to be collected to build out a database to help quantify the mixture's ability to withstand cracking. The first research study was completed in 2015, and by the middle of 2016, IDOT began their iFit pilot projects with 11 projects across all 9 districts. Pre-construction distress surveys were conducted, and the department made plans for annual coring for iFit and distress surveys. By 2017, all IDOT iFit machines were online, and uniformity studies began. Another research study with the University of Illinois began to evaluate long-term aging effects on asphalt mixtures using the iFit and to develop long-term aging, our long-term aging protocol, which was then completed in 2019. And by 2022, iFit was fully implemented. Looking at our testing overview, we have our Hamburg wheel and the iFit tests. We use these for each new mix design and the start of production for each mixture. And the contractor compacts the cylinders and submits them to the district, where they randomly select which cylinders to cut and prepare for both performance tests. For our Hamburg, Illinois modified AASHTO T324, and these are the specification limits for the following PG grades. You just take a look up there. And for our iFit, we also modified AASHTO T393, and these are our specification limits for short-term age specimens and long-term age specimens for surface mixtures only. Now, looking at the mix design process prior to 2019, contractors completed a 4-point mix design every 3 years and submitted it to the district, and the district verified it. Now, in our current approach, IDOT and the HMA industry now allow unlimited mix design length with some additional caveats. The district verifies the initial mix design, including performance tests, and we update the GSB values annually based on the IDOT GSB list. So every year we conduct technical working group meetings with districts, central office, and FHWA. And we also have joint meetings with industry to discuss and collaborate on various topics like performance testing and specifications. Some other goals of these meetings is to address issues and concerns brought up by industry and the districts. We also discuss research findings, and we identify focus areas for our upcoming construction year. Thank you.
So we're gonna have a panel discussion here, but I think we're already 50 minutes into the break, so I think we'll, if you could catch one of the speakers if you have a question during the break or something. So thank you very much, all the speakers, and enjoy the break.
So why don't you come up here, Monica, and give them your presentation.
Perfect. So I know we're talking about DPS, and my slides are from the MATC because that is where our equipment loan program comes from. Ooh, I went to the end. Okay, there we go. So we do have an equipment loan program, which is one of the best things that Federal Highway has to offer, because you get to test drive the equipment before you actually buy it to see if it's going to work for your program or your projects. And with that, we do have kind of like a 6-step proposal where we have an equipment loan request form. We have a kickoff meeting where we get information on where what projects you're going to use it at, what your goal is, the intended goal of the loan. And then with that, Mercedes and I developed 2 trainings, and these are usually held virtual. They did start after the pandemic, and so we call it DPS 101, where we talked a little bit about background of the DPS and how it works, what it's used for, and how we get to the end result of it. And then the DPS 2.0 is more detailed on the equipment that we're using. And so that goes hand in hand with the equipment that you'll be receiving, how to put it together, how to take it out, how to care for it, and how to return it. We also offer a field demonstration. A field demonstration. And with that, we help with the collection of data and the analysis of data. And then we all, like any federal highway project, we have a report and a closeout meeting. And so for this year, from 2023 to 2024, we started off with a lot of virtual trainings. And the equipment loan program does not only target state DOTs, we lend it out to industry, academia, and other government agencies. And so we've done some virtual trainings, but we're getting ready to start some of our in-person trainings. We've done the virtual for Arkansas, Wisconsin, and Iowa, and we're working on setting up a site visit where we get to collect data with them side by side and help them train. And then we're also working with University of Illinois and Asphalt Materials Inc. later on this year. So I just wanted to show on the map where we're going to be and where we have been. And then with that, from these trainings, we always get a lot of frequently asked questions. Everybody in the use of the equipment is at different stages of the use of the equipment. And with that, I'll pass it on to Mercedes to let us know about what we worked on.
So I'm Mercedes Kuznia with MnDOT's research section. Monica and I created these videos to assist with the training programs. Since we're doing a lot of the trainings virtually, people don't have an opportunity, if they have used the equipment, to see the hands-on training yet. So a lot of these are just short little videos highlighting like air calibration, equipment setup, things that are a little easier to see from somebody who's done it before, how to plug in a cable. So very basic, just to help people who have never used the equipment before. We do have 17 videos currently, and we are working on a few more. If you have any suggestions for video content or feedback from what we've already created, let us know. Our contact information is on the slide.
I also added a couple of tools. If you're interested in the equipment loan program, the link is on there. You could always send me an email, and then we also have a link to the pool one on there. Oops, sorry. And that's it.
All right,
Thank
thank you
you.
very much. Yeah, so, yeah. Great job. So I'm gonna blame John Garrity because he started the forced analogies. And I would just say, you know, Mercedes kind of undersold it as, oh, it's easy stuff like plugging a cable in or leveling off your sensors and things like that. But those are kind of the most critical things because we need to have quality data to be able to make the beautiful plots that Amy from North Dakota is going to show, that we're going to get from Amanda and Transtec. And so I would say that without people like Mercedes and Monica, it's like trying to put lipstick on a pig. So, yeah, thanks. Your fault. All right, so with that, I'm gonna take a little bit of a step back here, and we're gonna get into some background of the pooled fund that we have currently and the one that is currently being solicited for DPS. So just a little background here. What we're all about with the DPS pooled fund is putting out information on how this new technology can be used. So we have this DPS digest that we've put out 4 or 5 per year is the goal there. We have training and peer exchange opportunities throughout the year. And then, of course, we're trying to, as much as possible, work with other ICT technologies so we get a more full-scale picture of what's going on with our paving, because DPS is just one aspect of it, trying to map out the full coverage density. But that's, of course, a function of all these other great intelligent construction technologies. So this is our kind of outline of a work plan. The only reason I put that there is to let you all know we have a work plan that we're working off, and basically what it's trying to do is build off some of the specification work and research that we did in the first phase. So this example here is going to be published this year for getting dielectric of gyratory samples, and that allows us to track the dielectric, which is what we measure, to make sure when we convert it to density, we get accurate predictions. We also had, and UNH, I should say, Joe Sias, UNH was instrumental in that. Fabricio Leva, formerly from NCAT, helped us out not only with the laboratory work, but also did some kind of candidate and reference profiles to let us know, as this new technology and ways of collecting data is coming to the market, how can we evaluate it to make sure it's of the necessary quality and repeatability when we get it out there in the field. And then we put it to a vote to the members to see, okay, this is what we've done, where do we need to go from here with DPS to get it more widespread deployment. So I just wanted to touch on a couple kind of new developments that this next phase of the pooled fund is going to handle. What you see on the right there is a DPS sensor that's mounted on a roller, and a recent technical working group for our DPS pooled fund discussed and showed some of the results that they're getting when the DPS is mounted on a roller versus what we've been doing, which is just mapping it out after the final roller. And as you can imagine, that's has a potential from a quality control point of view to really help us out on this effort. So not just see how they did at the end of the project, but also monitor how many passes are getting our kind of leveling off of our compaction curve and things like that. And all this stuff, I think, my opinion, is working towards having all these different devices interconnected so that we're making sure we build it right in the first place. And then the one on the lower right is a 3D radar, a contour version of it, which has a much denser grid of sensors, and we're going to try that one out this month. They just came out with a new module to allow us to do dielectric mapping with that one. So we have to be able to handle that. And so all these improvements, as they come to market and as they become available, the pooled fund is working together, like I said, with kind of a peer exchange approach to try these things out and move on from there. And I just highlighted the advanced analysis techniques. I think what Amanda is going to be presenting with Veta is a big part of that picture. And then, of course, this slide that I'm highlighting on the right there, that was presented at our last peer exchange work plan update by Brian Nagel from Caterpillar. And that's what I think where we need to get with deep on a lot of these other technologies. Instead of a forced adoption or just a natural adoption, just hope it works. We need to create a situation where it's incentivized so the contractors can make money off of it. And then, of course, as an agency, we want to get longer lasting payments because of it. And I think some of the data you'll see today is should probably convince you that that's the direction we're going with this. So shameless plug, pull your phone out and do that QR code if you want to try to convince your state agency to join our next version of the pooled fund. It's open and it's going to start next year, at the beginning of next year. So with that, I am going to pass it off to one of our favorite pooled fund members, both NRRA and DPS, is North Dakota. So Amy, if you want to come up here and present some of the work you guys have been doing.
Great. Well, thank you, Kyle. And before I get started, I have to give a few thank yous and kudos to some people in our state. I'm here sharing this information. A lot of the success of what we've been doing with intelligent construction technology really goes to Kurt Dunn in our Grand Forks district and also John Stork in our research section. So thanks to them. I wanted to share a little bit about our construction program, just so you can kind of get a framework of what North Dakota builds. So this is kind of like a 15-year look back on our construction program. So like right now we're after you see kind of that spike, that 3-year bump after the IIJA funding bump, we're at about $600 million for our construction program. So if you're from a really large state, you're probably like, that's cute. But for us, that's what we run our whole program on. So it's really important we work within these numbers. You know, in terms of what we spend that $600 million on, if you look at the chart on the left, the section in orange is our paving materials. So about half of our construction budget is going to our paving materials, which is just a handful of bid items. And I think that's really similar in other states. So that kind of tells the story that if you're spending so much money on a handful of things, that quality in those handful of things really matters. So these next couple slides, these are courtesy, the statistics are courtesy of our construction division. So it kind of tells the story of inflation. So you kind of see way over on the right, it shows those bars in orange is our construction funding levels every year. And the gray bars are how many projects we are bidding with those, with our funds. So back in 2020, we had about a $400 million program. We bid 193 projects. Currently, we have a little over 600 million and we bid 168 projects. So we are essentially doing less projects with more money. In our ideal world, that would be flipped, right? So that's kind of telling the story of inflation. So our money is not going as far. So it's really important that we're really getting quality in our projects. This is kind of just showing the bidder competition. I don't know if there's similar stories and all the states you're from, but we're looking at our bidder competition is really declining. We're only seeing about 2.58 bidders per job. We've actually seen 9 jobs this year with 0 bids. So bidder competition in North Dakota is really, really low. And just the story of inflation, once again, we've seen, you know, that really initial big spike of 26% from 21 to 22, 13% from 22 to 23. So construction is definitely a real thing, which kind of gets into like why I think ICT is important. Back when we joined NRRA in 2018, I thought it was super important. And now that I see how tight our money is getting, I think it's even more important. One of the reasons we were really interested in it in North Dakota is because we were really interested in moving our density targets up. So that's kind of what piqued our interest. But I think it's just overall a great holistic approach and system for quality. So some of the things we're exploring in North Dakota, we're looking at intelligent compaction. We've been looking at paver mounted thermal profilers. We've been looking at the DPS. So DPS we've been collecting as kind of a research initiative. Intelligent compaction and paver mounted thermal profilers, we've been putting those on projects as special provisions. And then we also have a plan to implement e-ticketing. So this kind of shows the story of density in North Dakota. Our densities were really, really low several years back. Part of that was because our specifications were low. We also did not have an incentive. We disincentivized contractors if they didn't meet a certain density, but that was probably lower than it should have been. And when we really started digging into the data, we kind of noticed a shocking trend that contractors were almost paving a standard practice and a slight disincentive, which is not where you want to be. So we've really, I think thanks to NRRA, we've taken bits and pieces of things and we've really improved our specs. Kind of wanted to keep this around the theme of implementation, but you see like over the years, you kind of saw our density numbers across the board really have gone up across the state. So that's great. That's really what we want to see. In terms of 2023 projects, we put the SP for the paver mounted profiler, thermal profiler, and intelligent compaction on 10 projects. We are not a percent within limit state. There's not many out there that aren't, but we've explored percent within limits the last couple of years. So we did a few pilot projects there. And also Super Pave 5 was kind of something we're dabbling with a little bit to see if it's something that's a good fit for us. So moving into 2024, these are the projects we intended to do. So 13 for IC and PMTP. We have a machine guidance milling project. That was part of an innovation program pitch that got accepted. A few more percent within limits projects and the Super Pave 5. Now this is what we intended to do because of funding. I think a few of these are gonna get pushed to the next year, but this is kind of what we got on the docket. So this is really tiny. I don't expect you to read this, but this is kind of showing how we are improving our specs. You know, we used to think that if you had higher grades of asphalt and lower grades of asphalt, you could have a higher standard for the higher grades and a lower standard for the lower grades. So we've kind of changed our tone on that. We think that density is important no matter what the grade is. So we have been able to move our specs to just one standard acceptance table. We've moved the bottom up so that the remove and replace is much higher. And we've also moved the top end up too. So that's great. So this slide is kind of my favorite slide. And this is thanks to Aaron's section. Kaylin in his section crunched through a lot of numbers on a lot of paving projects. And so this is kind of, if you look at the chart on the left, it's saying that we looked at the 10 projects that we had the intelligent construction technologies on, and then we looked at 49 projects that didn't. And they're all held to the same standard. They're all held to the same pay table, but we did see almost 1% higher percentage in density compared to the ones that didn't. So just by having the technology on the project, that's an observation we saw is that just in general, the quality seemed to be better. We also saw just left failing cores or cores that are in a disincentive when that technology was present on the project. So that is awesome, because that's kind of like a well-known fact in the paving world, is that 1% kind of translates to about 10% service life. So for the win, positive observations we've seen, we do think we've seen the densities increase. There obviously could be other factors, but the technology appears to be positively influencing our densities. We see that standard deviation decreasing, and then we're also seeing less deduct cores. So when it comes to the DPS, density profiling system, we got into it because of NRRA. So we joined NRRA in 2019, and Kyle actually came over to a project on the east side of the state in Fargo. He met us out there, collected a day's worth of data, and then did a little short show and tell peer exchange with us. So that's that picture from 2019. We were sold enough that we bought the unit in 2020. 2021, the Matsu trailer was out in North Dakota, so we had some opportunities to do some peer exchanges there. And since then, we've just been collecting and analyzing data. So originally, there's kind of a learning curve. You know, we would get out and collect when we can. Now we're trying to get out and collect longer stretches of projects. So 2023, there was a couple projects that we collected pretty good chunks of data on, and I got a couple of slides to show you on that. 2024, the balanced mix design project that Aaron talked about, we plan to be out on that a lot potentially. We'd like to be out on the stone matrix asphalt project out on the interstate. And then one thing that we'd like to explore is the vehicle mounted collection versus like the push cart collection. Maybe just with our rural paving setups, we still do have some safety concerns with the DPS and having somebody walk so close to the center line when you've got trucks pulling into the paver and things like that. So that's one thing we're kind of really looking to see in the future, is to get a better way to collect the data that's actually a little bit safer. So here's a few field observations from North Dakota 17. So I think one of the things that really tells the great story about intelligent construction technologies is you maybe start to see things that you maybe didn't know were problems. And so when you can visualize those things and you have the data, you can start to actually make progressive progress and change towards them. So the example I'm going to share is the calculated density versus ordinary compaction. So on North Dakota, we only do the compaction adjustment factor, or the incentives and disincentives on the main line. So not the shoulders. Shoulders are just ordinary compaction, which pretty much says you have to roll it. So we're not going to pay incentives on the shoulders. We just do a straight up ordinary compaction. So this particular project, North Dakota 17, it was becoming very obvious that when you don't put a lot of emphasis on something, it shows up in the quality of your product. So you can kind of see here that the purple is more passive, kind of out on the shoulders, where it's orange, it's less passive. So there was a couple of observational cores taken very close together, but you can kind of see where they're getting paid, we're getting a lot better densities than where they're not getting paid. So this has actually kind of triggered some potential pilot projects for doing calculated density on our shoulders here this upcoming year. So I think it's really powerful when you can start layering all these ICT tools together. So it's not like DPS on its own, IC on its own, thermal. These are the Veta versions of the DPS data collection, but you can kind of see the red is where it's showing a lower dielectric or a lower density. So you can, that very much correlates with the pass count, right? And then here you kind of got those things stacked up. One thing you see, like the blue bars, that's the paver stops. So one thing that the paver stops really seem to create a disruption in flow. So if you go down to the middle section, you got that paver stop in blue on the top, 10-minute paver stop. So you kind of see to the left of it, it's kind of disrupted the flow, so it looks different on one side of the paver stop to the next. Whereas if that paver kept going, it would just continuously be smooth and compacted the same. So. Great. So the last thing I wanted to mention is ride. So ride is something we've been measuring for a long time. And now you can start measuring or kind of layering the ride onto all these other things. But like, here's a really good example that we have like that paver stop in that 10-minute paver stop on the left, and then we've got one on the right. And that really correlates well with that spike in ride, right? That roughness, that bump. So it's really powerful to see all these ICT tools coming together, and it really helps us make more informed decisions of where our specs should be. E-ticketing is not really my wheelhouse. This is headed by our construction services division, but it is an initiative of the North Dakota DOT. So last year we successfully used it on 15 projects. And really, we've got a plan to fully implement by 2026. One of the things we did was we acquired Hogh just to be able to unify the collection of all of that. So lastly, I do think there's a lot of really, really great things coming out of ICT. There's a lot of challenges. There's definitely a tech integration learning curve. You kind of got to vet the new while you keep doing the old. There's definitely some survey challenges. Cell coverage is an issue in North Dakota. We don't always have the greatest cell coverage in some of the places we want this. And it's also just because all of these materials are such a big part of our construction program, sometimes changing the process to accept them can be really, really challenging. But that is all I have. Questions?
Yeah, any questions? Or first. Okay, all right, well, we'll keep moving. Oh, yep.
Just hotness asphalt, but the intent would be to allow it for other things like ready mix trucks, things like that. So, but right now I'm pretty sure it's just been on hot mix asphalt.
Okay, thank you, Amy. So I'm gonna share just a little bit about the full coverage testing that Mercedes did last year. And she also trained in some contractors to collect data. And the focus here is on incentive disincentive, because I think that's the justification for the technology. Just to put things in perspective, you know, this is one project on Highway 22 where there was 63 paving miles tested, and that corresponds to 570 passes with this cart. And thus you see the segue there. And as Amy mentioned, you know, safety is an issue, and that's one of the reasons we're excited about some of the developments that are occurring from a data collection options point of view. Just wanted to mention quickly that AASHTO spec that we showed earlier is working well to be able to track the dielectric properties of the mix. It's really critical for us to non-destructively be able to identify if there's a change dielectrically. Typically there isn't, but this is just an example here where there was a blend change that did change our dielectric properties, and that's something we need to track, especially if we're going to use this technology for acceptance. And the e-ticketing, I'm excited about that too, because then we'll know exactly where that mix is going on the project. I also did want to briefly mention, this is kind of the ideal where you already have your full distribution from doing day after day of the same mix of cores. And we have our millions of data points from our dielectric full coverage to get a really reliable conversion from dielectric to density. But we know the goal here is to reduce the amount of cores we need to take. So we've had some encouraging results using a self-similar mixing model, and my understanding of this model is it doesn't try to take the different dielectrics of all the different constituents. It just simplifies things. Where basically, if you know a reliable dielectric for a reliable percent GMM, you know the change based on air is going to be the same regardless of the mix. So it's kind of a simple model, but it's proving to be a really effective model, where you see if you just compare these two different curves, they're really on top of each other for the most part. This is just an example day by day, and this, these ones where it is flatter when you use the actual cores, that's actually just due to the limited number of cores. So any of you who use a PWL where you're trying to use a limited number of cores, you can't really characterize the variability all that well trying to extrapolate from that. So we're excited about the ability to do our conversion with less cores using this type of a model. Getting to the incentive-disincentive discussion, we're basically separating it out in Veta to the different filter groups that basically change day to day or based on if you change lifts and things of that nature. And then what we're doing here, again, I'll kind of just give you an idea of the magnitude of the amount of data that was collected, and then I'll go in more detail on the incentive-disincentive at a conference in Orlando that I'm sure Amanda's going to plug at the end of her presentation. But so we're paying $52,736 on this Highway 15 project just based on the cores. And the idea is to take these projects where we have all this full coverage data and say, well, what are we paying based on this limited core information? But what could we be doing from a performance perspective with all this full coverage data that we're collecting on these projects? This is just another project that they did outstanding on up by Duluth on Highway 1, average density of around 95. And again, incentive-wise, based on limited cores, there's only so much you can pay out on projects like this where they do a really, really good job. So just a little bit of a teaser for the Orlando conference in September. Highway 35, I just wanted to show a little bit of a breakdown of if you take these different filter groups and you say, okay, on the x-axis here, we have how much we paid out based on cores, and then an example criteria. In this case, we just said, for all these hundreds of thousands of data points, let's break it down into 150-foot sublots and say what percentage of these sublots are at 93% GMM or higher, and see how that affects our payout. And you do see a good agreement, which was pretty impressive to use those limited amount of cores to be able to do a pretty good job with the payout based on our current spec. But I think you'll see, there's a couple examples where we paid $4,000 on one day where we only got 10% of this really stringent criteria, and another day where we had 30% meeting the stringent criteria that got a disincentive. So those are the kind of things that I think with the full coverage data, instead of paying out on a kind of lower magnitude because we don't have as much certainty with our assessment, we can start to really pay based on our performance, because we know certain projects are going to last a lot longer and obviously save us a lot more money as an agency. So with that, I'm going to pass it to Amanda from Transtec, and she's going to kind of tie everything together from an ICT perspective, and also, I think, mention a little bit of the latest developments and trying to get stuff a little bit more real-time and on-site type analysis. So with that, let's welcome Amanda.
Hello, everyone. If we have not met, I'm Amanda Gilliland. I'm with the Transtec group. But I have been a Veta user for a long time. I've been a Veta user before I even started with Transtec. So I've been using Veta for over 12 years now. Started out using it when I was still a contractor. And so what I wanted to show you today really is just kind of what is Veta, how can you use it now, what's coming really soon that's really exciting, and where are we going in the future. And before we start, a lot of my data that I'm going to show is borrowed from different states, different projects that I've seen. So if you see some familiar data, thank you for sharing, Kurt and Amy. I have a duplicate slide in here that you literally just showed, but it's such a good one that I think it's worth looking at again. But so let's just jump into this first little bit. So I just want to start out, we're going to just kind of look at some fun stuff about Veta. So what is it? If you aren't familiar, Veta is a standardized software platform that is compatible with many intelligent construction technologies. So originally, we developed it back a while ago for intelligent compaction. And so what we were finding with intelligent compaction is that, hey, there's a lot of different vendors. Every vendor has their own software. And it doesn't really make a lot of sense for us to try to learn and understand every vendor's software out there. What if we just had one program that was compatible with all of the vendor's software where we could look at it and we just had to learn the one program? And so that's why Veta was developed. So all of the different IC vendors had a Veta file that you could just learn Veta and look at all the data. And it's grown since then. So now it also includes paver-mounted thermal profiling and the dielectric profiling system. And very, very soon, it's going to include MDMS. So MDMS is the Material Delivery Management System, and that includes e-ticketing. So we're going to talk about that in about 10 minutes. So a little history, I kind of touched on this. Originally, it was funded by FHWA and MnDOT. The idea was, you know, how can we use this to make it easier to look at the IC data? Currently, it is supported by NRRA, and we have the technologies I mentioned. Where we're going with it, so the two big things coming up are the MDMS, which we'll talk about, and then also it's going to be web-based, which is super exciting. So I'm going to talk about that a little bit as well. And then there's lots of plans to just kind of continue building on it, adding technologies and making it really just a nice way to store all your construction data or all your project data in one place. So one of the really cool things about being able to pull all your data into one software program is it just makes it really easy to kind of find, you know, these trends, the things that Amy was mentioning. It's like, once you have that information, it all really kind of starts to make sense, you know? If you have a core with a low density, you know, that doesn't tell you a whole lot. You know, was it just one kind of bad area? You know, is the whole thing bad? Like, we don't really know until we start doing some forensics. And with these technologies, it makes forensics super, super easy because you can just come in and look and say, okay, well, here's where my core was. What were my temperatures behind the paver? What were my roller temperatures? How many pass counts did it get? You know, there's only really so many things it could be, and it just kind of makes it really easy to go in and take a look. So this example here, you can kind of see we've got our information from the paver. And you can see a paver stop right there. And right where the paver stopped, we cooled down to like 160 Fahrenheit. So does anyone think we're going to get, you know, good consistent density at those temperatures compared to when we're at 260? Probably not. And then you can see in the DPS data, estimated density, you know, sure enough, it's low, really low. And, you know, you can see in the middle of the IC passes, well, we had enough passes, you know, we had plenty of passes, but the temperature was too low. So of course we didn't get density. So let's just jump in. I'm just going to kind of go through some of these case studies. The first one we're going to look at, this is just looking at PMTP. And so I got this data from a contractor last year, and they said, hey, we have this new PMTP spec. We aren't meeting our thermal segregation. We're getting severe thermal segregation. Do you think you could help us troubleshoot? And so I kind of took a look at the data and I said, I think I know your problem. I think it's your paver stops. So you can see all of those little red dots up at the top indicate a paver stop, and then it has the duration. So the bigger the dot, the longer the duration. So we're ranging from, 7 minutes up to, nearly 40 minutes. And so with each, paver stop, you can kind of see there's lots of things happening. We're cooling, stuff sitting around, the rollers can't get up there to compact it. And so they're ending up with their severe thermal segregation, which we know is going to lead to other issues with smoothness, density, and all the other things associated. So, if they didn't have this technology, it would have been a lot more difficult to kind of try to troubleshoot any sort of low density or anything like that. It's really hard to say what's happening. We don't normally have a record of when the paver stops for a very long time. So now let's kind of compare that. Let's kind of just add in more technologies. So this one on the top, we're looking at our PMTP. The bottom, we're looking at our density from our DPS, and they're almost kind of like mirror images. So where our temperatures get really cold on our paver, our density gets low. And it's not rocket science, like we all know that, right? We all know how important these temperatures are with asphalt. But now we can actually really have the information and see it and see how often it happens and then try and fix it, right? And this is super common in a lot of the data we see. A lot of these trends I'm showing are trends that kind of are reoccurring. So again, with paver stops, another example of, of course, it's going to affect your density here. So if you're on a paving project and there's a lot of paver stops, that's a problem. How do we mitigate that? How do we improve our paving practices to stop less, right? And I know it's an issue. Trucking is tricky, traffic is tricky. Like, we know that there's some things to overcome there, but the big thing is like we know how much this is affecting the quality, right? And does this look familiar? So this is another really common one. So Amy just showed this, but I love these slides. I have one more right after this because IRI is so hot right now, right? Like it's always been a big deal, but with sustainability and seeing how much that impacts, during the use phase and greenhouse gases and everything, smoothness is so important, right? So I think we're going to see, a big push to really get the best smoothness possible. And so having tools like this where we can kind of monitor what's happening on the paving project and make changes appropriately are going to be really important. So here's another one, different project, same kind of concept where, everywhere the paver stopped, if you look at the corresponding IRI data, there's a little area of localized roughness. So, pavers really aren't meant to stop. I'm sure everyone's heard the water ski analogy, right? But if you are water skiing, do you want to stop frequently? No. Do you want to speed up and slow down frequently? No, not really. You want your guy on the boat to go nice and consistent. And the paver screed is set up very similarly. So consistent, nice, steady movement is what we're looking for. So this is a tool in Veta that I don't know if a whole lot of people know about. It's one of my favorite tools in Veta. It's the heat loss curve. And so if you put your PMTP data and your IC data into Veta, you can look at all the temperatures on one chart here using the search tool. So time 0 is going to be your temperature right behind your screed from your PMTP. And then all the other temperatures are going to come from the rollers, and it's all shown over time. So all of the data is time stamped, so we can make this curve very, very easily. So one thing I like to do, if I get any data in and there's anyone having issues with density or anything, this is one of the first things I'll come and look at is what did this curve look like at their core location. So a couple of things you can see, that the time between 0 minutes and that next point, that's going to be how much time passed before your roller got to the mat compacted. And then you can also see, how long you're compacting it for. So if you recall from this morning, if anyone can remember that far back, There's tools available where you can plug in your mix information, your location, what you're paving on, the weather, all that different stuff, and you can get an idea of how long you have to compact your asphalt. I use it all the time as a contractor. I use it all the time. Great tools. And then now there's a tool in Veta where you can kind of go and say, well, am I needing that? And this data I'm showing here was from a project with low density. And they said, hey, we're getting good density on the project. And then all of a sudden we get a low pour. And the contractor says, you know, it's a fluke, he doesn't know. Can you take a look? And so I took a look at the core that failed, and you can see that, you know, the compaction window they had, they should be done rolling, you know, maybe 12 minutes. Well, the rollers didn't even show up till 20 minutes had passed. So kind of a red flag. So then I started checking more locations on the project, and they were all over the place, right? So these are all the same day of paving. It's a lot to look at. I'm going to explain what I'm trying to show you here. So those red crosshairs are all showing the exact same temperature and time passed. So in theory, those crosshairs should be in about the same place, right? So here we are in one location. We're almost 300 degrees behind the paver. Rollers are getting there about 6 minutes later. We're done compacting within about 10 minutes. Density's good. We're good. Okay, the next one, a little ways down the road. We don't even get the rollers till over 15 minutes has passed, and it's only 245, 250 behind the screen. So that's a pretty significant drop for one day of production. And so it's just all over the place, back and forth like this. And sure enough, you know, this is a really good example of when you don't have balanced paving. So this is when you need to kind of reassess and say, okay, what's my trucking like? How fast is my paver going? If I had to guess, the paver was going too fast for the rollers they had on the project. And it's something that everybody knows to do. We talk about it all the time, but now we have the tools to look and see if it's being done. So here's some more stuff on temperatures. When I was quality control manager for paving contractor, I was obsessed with temperatures. Temperatures is everything with asphalt. This is a really good example where, you know, they were getting low densities. You can see the DPS data on the right, kind of low. And so you can do a lot of really cool filtering in Veta. So they applied a filter that says, okay, show us all of the passes that were made when the temperature was above 210 degrees. That was the threshold they kind of had. Only one. So only one pass was being made when they were at that kind of threshold that they knew they needed to be at to get density. So they made some changes to the paving operation. Density got way better. And when they applied that same filter, they were up at, you know, 3 to 4 passes of that temperature. So just really cool to be able to go in, take a look at data, see what's going on in the project, and just make positive changes to your paving operation. This is one I see all the time. This is one Amy mentioned too. Nobody rolls the edges of pavement. And it's pretty much permitted in a lot of specifications. So when I was paving, the really common specification was, we aren't going to take a core within 2 feet from the edge. What does that tell me as a contractor? I don't have to get density within 2 feet from the edge. And it doesn't mean they're bad contractors. It means they are delivering what they are being asked to deliver at the lowest price, which is part of what we're asking, correct? So, you know, we just need to be careful. It's a good way to go back and reassess. Like, is that what we want? Is that, you know, acceptable quality? But yes, not rolling the edges is very, very common. And we see it all the time. So again, just kind of showing all these different examples, that it all ties together. It all starts to make a whole lot of sense. And there's definitely a lot that we can learn from this. One of my favorite comments I got from a contractor implementing this, and it was supposed to be a negative comment, but he said, well, all this is doing is just ensuring best paving practices. And I was like, yes, that's exactly it. You get it, you know? And he was just trying to argue, like, we don't need it. We know how to do this, but it's like, no, we do need it because it's good for accountability, it's good for record keeping. One thing I want to point out too is look at this, look at all this data. We're using IC data and we're still having issues. It's not foolproof, right? You have to use it and you have to make decisions with it. So just putting it on the equipment is not going to solve your problems. You have to take the data, you have to look at the data, you have to make the improvements. Okay, so now let's get into the next best thing, going into Veta, MDMS, Material Delivery Management System. There is an AASHTO specification out there for it. And what is it? What is MDMS? So this is e-ticketing, but it's more than e-ticketing. So, e-ticketing came out, it got real big real fast. It was great through COVID, right? It kind of blew up because it was such a great tool that, everybody was really excited about. There's a lot of vendors out there now that do e-ticketing. Lots of different vendors. We don't want to learn a lot of different softwares, right? So again, if there's a need for some sort of like standardization to where we can look at the information and get the information in one place, regardless of what vendor is supplying the information. And then there's also a little bit more than that, right? So when you're out on a project, you're getting tickets, your inspectors taking tickets, whatever. Sometimes we're writing notes on those tickets or we're doing different things with those, right? Like we might make a note of the asphalt temperature on delivery right there on that ticket, right? So, what is a ticket, right? Like how much goes into a ticket? And so MDMS was developed as kind of like here's kind of the things that could be in a ticket that we might want in a ticket. And it has all these different categories. So of course you have the ticket, and then you also have the loading and delivery events, hauler information, testing and contract administration, and agency verification. So I'm going to go over each of these little bubbles. So the first one's your